Hey everyone, welcome. So we're live. Amal, you want to
Yep.
go ahead with the introductions?
Yes.
You,
Yep. Hey, hello. Welcome all to the first ever edition of the .NET Conf Kerala conducted by MobConf in association with the .NET Foundation. So before we start with the online sessions, I would like to introduce you to the speakers and what all the topics we are covering and how the whole event will pan out for the rest of the day. The first talk will be by Nish Anil. He's a senior program manager with Microsoft on the .NET team. He will be taking the session on microservices in .NET. Basically, he will be going on what all are the latest in Microsoft microservices offerings in .NET 5 and from the .NET framework. And the second session is by me, Amal Dev. I am a Microsoft MVP and works as an architect at KPMG. I'll be taking you through how to build dynamic websites and host it in Azure Static Web Apps. And basically, the last session will be by Swami. Swami will be talking about how we can make use of gRPC and build sites using gRPC with full stack applications in .NET 5. So, uh, uh, regarding the session and how you can interact with the speakers, you can use the chat box window uh, for sending your questions, and we would like to make it as an interactive session. So if you have any questions, just shoot it in the chat window and we will uh, answer it along the way. So again, welcome you all to the event, and with that I am handing over to Nishanil to take the deliver the first session. Thank you.
thanks a lot, Amal. Hello everyone, welcome so much. So it's been amazing. So my name is Nish. I work on the PM. I'm a PM on the .NET team. I work on the .NET architecture. So today's session, what we want to do is we want to keep it more interactive. So feel free to drop in your questions. I do have a plan. I do have some specific demos that I'm going to cover. But if you have questions on microservices, if you have questions on .NET, feel free to ask the questions. Drop in those questions in the YouTube chat window, and that will come to us. So it's about 30 seconds for it to show up on the stream yet for us, and then another 20-30 seconds to show up on the screen. So remember that. So we want to keep this more interactive because I know like we have been working from home for a really long time now. So we will make it more interactive because we are not being able to meet in person. So last time I was at MobConf, it was while I was working at Xamarin. It was a few years ago. So really, really excited to be with you all today. All right, so this is about me. This is my handle, Nishanal. You can follow me on Twitter or Instagram, wherever you like. So I'm going to talk about microservices. So this is my, what I do at Microsoft. Like I manage the .NET/architecture page. So we're going to go into all of those details. So this is all the slide that I have, and rest of the things we'll go hands-on, do demos, answer your queries and such. Right. All right. So let's get started. So if you're new to .NET, what you can do is you can open the browser and go to this page called .NET. This is a great place for all the information that you need for .NET to get started, right? So here you see something called as microservices. So we build this specific page to get you started with microservices. So what exactly is microservices, right? Microservices are a design pattern in which applications are composed of small independent modules that communicate with each other using well-defined contracts. What does it mean? Well, they are not services which are small, but they are services which have definite boundary, the business boundary. So if you have like an application, you actually break that into multiple smaller services managed by independent teams, so you can actually scale quickly. So you've seen that all the latest applications now, they're able to ship things to productions maybe 100 times a day, right? So how can they do that without breaking the entire application? And that's because they follow this microservices architecture, right? So that's a design pattern. Now we talk about microservices and containers too. Most often we speak about Dockers, Kubernetes, and all kind of things. Well, microservices architecture does not tell you to do Dockers and containers. Dockers and container tooling itself is so amazing that it just makes the simplicity in bringing the complexity down. So that's all about having containers and things. So it's not mandatory to start with Dockers and Kubernetes because Microsoft architecture is just the architecture pattern. But these tools definitely make it easy to get started, right? So if you're just getting started with microservices, and that's what we're going to go do, we're going to start with scratch. We'll start building a web API, and then we'll show you some gRPC. Then we'll go into TIE. We can go into handling resiliency in microservices, resiliency in core, resiliency using service mesh. So these are the things that is planned. But really, this is all about what you want to hear. So feel free to ask questions, and we can steer things that way, right? So you can start from here. Like if you're first time getting started with microservices, like how do you really get started, right? You need to create a service at some point. So you will start with something like a web API. So how do you do that? Like there are really well-defined steps out there. You don't need Visual Studio. All that you need is just go ahead and download this SDK. So if you go to this page, you have this place where you can start downloading. There you go. It started downloading. You just install it, and that's about it, right? Once you install it, you just make sure you run .NET, and then that is done, and you can get started here, right here. So we're going to do these steps, and you can see that these are running, installing, adding Docker metadata, and then running the Docker image and other things, right? So this is how you get started, right? Once you are comfortable doing this, you can go into the next step, which is about deploying this to Kubernetes, right? Once you have the image ready, you need to ship it to production, right? So there are steps listed out here. So if you look at to deploy to Azure page, you can see this YAML script that you need to create to make sure that your image is actually available for Kubernetes to consume, right? So there are well-defined steps out here. And for those of you who are like, oh, I know how to do these things, right? And I want to get started with just about understanding microservices. Maybe you come from the world of like you've been doing applications for ages together, like 10, 15 years in production, and you don't want to know now the new way of doing the architecture, right? So then you can actually choose this one, architecture guidance. And this is the page which I was talking about. You can actually reach to this page by .NET/architecture. And this is what I PM on. Like we maintain architectural reference guides for you to get started. So what we do is basically we understand from our customers how .NET has been used in production, and we kind of build out those best practices for you, everyone, to actually take and learn from. So there are microservices, DevOps, modernizing. Literally, they are all books. Those books are available online for read, or you can actually download this as PDF, right? So there's this. So if now we are talking about microservices, so let's get into the microservices world. So this is the book. This is one of our popular books called Microservices. .NET Microservice Architecture for Containerized .NET Applications, written by Cesar a few years ago, and now we maintain it. So if you go into this, it basically talks about how do you architect microservices? How do you do domain-driven design, right? How do you, start with Docker? How do you take care of security? How do you do CQRS? How do you build resiliency? So it all talks about everything .NET and the microservices architecture. Now, once you're comfortable with this, and if you want to go and learn, okay, now you're ready to build on production and you want to choose something like Azure for your cloud platform, technically you can actually use any cloud platform. But we specifically wrote a book on Azure so that, if you're actually looking for services on Azure, like how do I actually do Redis on Azure, then we actually have written those things in this book too. So you can actually, as I said, these are living documentation. So if you any point of time you feel that, okay, I think there's something here, there's something wrong, I need to fix this, you can actually go into this one called edit, and go to edit this document, and feel free to, they are all in GitHub, they're all open source. So feel free to go and edit and send us the PR, and we will be happy to merge them. Right? Or if you have any suggestions and other things, feel free to drop in the feedbacks and other things. So what I wanted to say is this is a living documentation. So we always update it, we keep it current. Now, the other thing is I know when you start learning, you also want to get the big picture, right? So we also built something called as a reference sample, which is called the eShop and containers. So if you open this is the page, GitHub page, where you have the eShop and container. So this is nothing but a simple e-commerce application. I mean, it could be anything. Microservice is not specific to e-commerce, but generally you'll see people talking about e-commerce application because it's easy to understand when you start learning, because you know the domain little fairly better than any other domain. So as you see that, this is the microservice architecture. And what I wanted to point you to is, let me just increase the screen a little bit. Look at the architecture for this application, right? So you have the client application connecting. There is a web spa. There is general MVC application, and there's also a mobile client. They connect with the backend services, and I want you to pay attention to the services, how they are built up, right? So there is identity, catalog, ordering. So you basically split up the large application and go into focused microservices. The most important aspect about it is, like, if you notice, they all have their own databases. So they don't share a database at all. Like, if you're building monolith application, and one of the bottlenecks of the monolith application when it comes to scaling is that, database is common, and you actually reference data in terms of relational tables. Now, that's a challenge, because now when you want to ship it to production, you want to make sure the other service is not breaking. So that's a bottleneck. And that's why you need to make sure the microservice is not about just the endpoints. It's about the entire business, right? You have to consider itself as an independent business unit itself. So most often in large companies, they even actually split the team accordingly, right? So you have independent services. So for example, catalog service, it uses SQL Server database, right? So when you go to basket markets microservice, it could be a completely different team. They have a different endpoint, and they will decide for data store to be used Redis cache. So that that autonomous aspect that comes into this thing, that's the most important thing. So you get to choose what technology you want and what database data store that you want to use, right? Now, how do you communicate with each other? Like service to service communication. And that's where you define well-defined contracts, right? So one service A, service B connecting, you may have a REST endpoint, you may connect with a gRPC, or you may completely go with something like an asynchronous messaging patterns like PubSub model and things. And you may use something like RabbitMQ, or in production, something like Azure Service Bus, right? So when the order is placed, I'm sure if you're shopping these days on the e-commerce sites, you'll know that when once the payment is accepted, they say, okay, thank you for the order, we'll get back to you, because it's not the same synchronous service. So because there may be a notification for another service to pick up and respond, then you'll see another notification coming up like, okay, this has been processed, we are shipped, and thing. So that way every single service is independent, right? And how these services communicate with each other, because these are independent services, they can exist within the same cluster or maybe somewhere else, but how do they connect with the world, right? How do the clients connect to this world is by using API gateways. So we define API gateways so that those are the only endpoints that are exposed to the clients, and then they help you connect to the microservices behind the scenes, right? There's so many patterns out here. So we explain a lot of these things. So if you find information here which is not sufficient, you can actually go to wiki, and we also define certain specific information in wiki, like what is the BFF implementation, for example. In this case, in API gateway, we kind of use the Envoy proxy now. Earlier we were using Ocelot. Now we use Envoy proxy. So like those design decisions that we make, it's also available for you to see in the wiki. Now, the other things that you probably want to take a look at is like, one of the key anti-pattern, I would say, for a microservices architecture is that you will not have everything in a single repo. Because right now in this repo, if you go to SRC folder, you will see all the services out here. So these are the services within the services section. So these are the services independently in using their own CS prods. They handle their own data. They handle their own databases. So all these things are in single repo, and that's an anti-pattern, because in microservices world, you want to have even the repo separately so that you actually check in the code and you ship separately, right? But that's the thing that we want to do with the sample, because at the end of the day, this is a reference sample that you want to get started with, right? So that's why we made it into a single repo, so that you can have that Visual Studio experience of running FI and all the services bringing up, and then they work with each other. But they're independent in terms of even CI/CD pipelines. So even though they are in single repo, their pipelines are different. So if you commit something into a catalogs folder, only the catalog API is built and pushed to Docker Hub, right? So those pipelines are well defined in this. All right. So I think we got into too much of information right now, but let's get back and we'll talk about how do you get started, right? So let's start with a simple application. So right now I have .NET installed. So if you just hit on .NET, you will see that you can actually go and say .NET version. So I'll tell you what version I'm running on, right? So now if you want to get started, you can actually hit .NET new and say hit, and this is what we're good with, right? We give you templates to get started so that you don't have to do everything from scratch. So in my case, for every microservice, you need an endpoint for the services to connect. Either the client connects to you or another service connects to you, right? So there are multiple endpoints I can create. For example, I can create a REST endpoint or a gRPC, which is the most modern way of doing things. But for now, I'll just keep it to Web API. So let's get started with Web API. So .NET Web API, .NET new Web API. I need an output directory, so I'll just provide it hello, Kerala maybe. So that's going to create a template for you with Web API. So if I open that in Visual Studio Code, you can see that I have this Hello Kerala application right here. There's a startup.cs, there's a program.cs, right? And most importantly, there's a weather forecast controller right here. Let me add this. Yeah. So this is where it's like this is something which comes free, right? Which is basically a random value of weather, because we want to show you how to write it. So you write a controller, and then you have the get method exposed as a HTTP get, and then it just runs as an endpoint. Now let's run this. So if I go into run command, so you can see that you can say start debugging. So it's going to run. So I did not do any code. I just simply run. So it just opened up here. So you can see that, all right, there's nothing on here. That's because this is an endpoint and we only have a weather forecast endpoint, right? But, we can also have a Swagger definition. So you can actually go to any application that you create now using Web API, basically the .NET New Web API. We add Swagger by default to your application. So that way you don't have to really worry about adding this to yourself. So this is the weather forecast endpoint I was talking about. So we can hit try out, execute, and there you go. That's the random weather that's coming. That's the JSON data that's coming back. We can actually run this directly as well on the browser. So I can copy this code from here and hit on the browser. There you go. That's the random value. Every time I refresh this, there's a new value that comes up, right? So that's a simple pair. Now let's take this to the next step. So how I want to Dockerize this, or before that, doing that, let me show you something. Like, where am I executing this, right? So because ASP.NET gives this nice dependency injection, so we also inject the logger when you need it. So we can actually log this information. So I'm going to use this logger dot log information here. And basically, I want to know where is this thing running. So I could say environment dot OS version dot version string. So I want to see where am I running this application, right? So I can now put a breakpoint in. I want to see how is .NET running this. So let's hit bug. Now I go to the weather forecast. And there's a breakpoint hit, and there you go. So the version string says Microsoft Windows NT 10.0. Nothing fancy here. This is great. You know that it's running on .NET, is running on Windows. But now let's take it to the next level, right? So now we're going to add Docker to this. So anytime you want to actually kind of like create an image out of it and then ship it to production, something like Kubernetes, you want to create a Docker image out of this. So to do that, now how do we go and do it? There are multiple ways to do that, but the easiest way, if you're using VS Code, is use Control-Shift-P, add Docker files to workspace. That's all you need to do. And now it'll ask you, okay, what's the platform that you're running on? So that's .NET Core. And now you can choose, do you want to run on Linux or Windows? You know that .NET is cross-platform. It works on all these operating systems. So now I can choose, I want to run this on Linux. And it'll tell you, okay, what ports do you want to expose? I will just keep it default ATN 443, which is HTTP and HTTPS. Just leave it there. And then it'll ask me, okay, do I want to include Docker Compose file? Which in my case, no, because I'm just working with a single service right now. But if you want to use like run multiple services, you can actually use Docker Compose as well. So what this is going to do is it's going to do only two things. One, it's going to involve a Docker file, and then it'll also add a Docker ignore file to the folder. So basically what Docker file defines is basically it tells Docker how does this project build it into an image. So that's what we define. So by default, everything is generated for you. So these are commands to Docker. So we say, okay, in Docker, generally what happens is you create an image, right? So in your image, you can say, what's your base image? Like you can say, okay, this is my base image. From this image, I want to create my image. So that's why you don't have to literally explicitly say what operating system you want to use, because the base image would have already had them as their reference in that image. So right now, in this case, I'm having the runtime, which is ASP.NET 5.0. I'm also doing one more thing is I don't want to build this image right here. So I want to build it right inside the Docker image itself. So I want to have this Docker container, and I want to build my source code. I want to copy the source code into the container and then build it right inside that, right? So these are the commands that will do that. Now, we'll not go into the details of it. You can see that, it's just simple .NET build, .NET restore, .NET build, and .NET publish. And then basically when you want to execute it, like something like a Docker host, when it has to run your application, it needs an entry point. So we are going to say, okay, .NET and this DLL that just created, that's going to be my entry point to this application. Fine. So we'll leave it there. Now what we're going to do is we're going to run this, right? So now if you go to the run command, now instead of Docker, I'm going to say, sorry, instead of .NET Core, I'm going to use this something called Docker .NET Core launch. So that's the run time I'm going to use. I'm going to say start debugging. All right, remember, I also put a breakpoint. And before doing that, make sure you have Docker running. So in my case, I do have the Docker running. You can see this. So Docker is running. So now it's the browser should be up. So you can see that this now it's no more from the 5001 port. This is the random port generated. So now if I go and say weather forecast, yeah, and hit my breakpoint, see I'm able to debug right inside the Docker. And you can see the version string. Now it says Unix 4.19 because now we are running it on the Docker image, which is running Unix under the hood. That is cool, right? So you can see how your code is cross-platform now. Which is great. So there are a few more toolings that I'll show you how things are working here. So here it is. There are nice tooling. So you go ahead and install this Docker extension in VS Code, and it'll give you this nice tooling. And there are tooling in Visual Studio as well that you can use, right? So these are individual containers. Let me see. Where is what did we name it? Okay. I think I just need to run it maybe. So let's go and run this file for now so that I know exactly which one, because sometimes it just puts this SHA values and I have no idea what it is. Okay, there it goes. Yeah, there you go, this one. So you can see inside this, there is files, and whatever we wrote in the Docker file, we have this app, and which is where we actually asked it to copy it, and from the bin folder is when it'll run the .NET run. Not this one, this one. And then there's also source folder where we actually copied it to build it, right? So that's also there. Okay, so that's pretty cool. Now, once you build it, let me stop this. Once you build it, how do you actually ship it to production? So now the image it becomes immutable. So now it has to be kept somewhere, something in real time. Like, I mean, if you have used FTP servers and other things before, during the olden days when we used to ship web application using an FTP, we could deploy there, right? Now, with Docker, you basically have a container registry. So you have to do a Docker push to a container registry. In my case, I have Docker Hub. So I can go and use commands like Docker push, name it, like basically tag it and push it. And in my case, I have my personal one, which is Nishanil. And this is where we're going to push Docker push, and we will have this image running right inside this. Now, within your Kubernetes file, you can say this is my Docker Hub or the container registry, and then the image name with the tag, and it'll know how to pull that image. So that's how things work, right? So that makes this building, making it immutable, and shipping easier, right? Okay, this is fine. So let's go and to the next step. Do I have any questions now? Okay, nothing right now. All right, so that's about getting started with Docker, containerizing, just about getting started with microservices, right? Now, there are a few things like, Web API is basically the standard way of doing things. Everybody uses it, and it's very well known. But the newest form in terms of services or creating service endpoints is gRPC, right? It's basically there are many RPC frameworks, remote procedure crawl frameworks out there, but gRPC has become the popular. It's cross-platform. It's part of the CNCF Foundation, so it has become the de facto kind of like RPC framework out there. So everyone works on gRPC these days because it has protofile as a contract, and service-to-service communication happens easily with the protofile. It's cross-platform, so that you something built on Go can work with something on built using .NET. So it's pretty straightforward. And the protocol, I mean, basically the entire data has been transmitted in binary, so it's much more faster than the JSON and the text and serialization. On the REST client, they are more readable for humans, but when it comes to gRPC, they are more machine oriented, so it's for not humans. So that's why you need great tooling support to get started with gRPC, and that's pretty much what I'm going to show you today. So I showed you VS Code and then starting with CLI and things. So let's go to the good old Visual Studio, which is a great platform to start with your code. So I'm going to create a new project and start with gRPC. So you can actually come here and search for gRPC. So this is the gRPC service. Click next. So gRPC service 4 is fine. I'm going to leave it there. Start creating it. I'm going to use .NET 5.0 to start. That's also good. Let's hit create, and this is going to start creating the web project there.
We have one question while we're here.
Yep.
So yeah, the question is, what is the recommended way of managing transactions across microservices in .NET World? From Jason.
Yeah, very, very good question. And I'll get to that, Jason. I'll park your question for some time because we're just in the getting started space. And we'll go into the details of, managing transactions, saga pattern. There is so many things like that. Actually, let me show you that. Like, I suggest you to see how we do that too. Like eShop and containers is a good example. Like, it has a couple of things like that, doing a transaction, compensating transactions and other things like that. So I'll show you, remind me to show this to you at the end of the talk. Like we do have written these things in the, in our documentations and guidances. So, okay, let's come back to gRPC. And the reason why I did not want to take that question is because a lot of you who are getting started probably can get confused with the transaction statement because it's slightly on the advanced side of things. All right, so this is gRPC service that gets generated here. So you can see that there's a protofile, which is create, and this is what defines, and this is basically language neutral. This is not C#. This is basically how you define protofiles. And so for now, I'm going to run this. I'm just going to build a service, and I'm going to run the service, right? So while this is running, you can see in the startup.cs, we have this configure endpoints. So which is now we have it 5001. Let's go and hit this page, right? So if you go into the browser, hit this page, it says communication with gRPC endpoints must be made through gRPC client. That's what I'm saying. It's not for human readability. So we don't have any Swagger, we don't have any endpoints that we can see. So it has to communicate with the client using well-defined protofiles. So now I'll show you the tooling involved in this to how to create this, right? So now we'll go and create a new application as a gRPC client, new project. I'll just create a console application. You can pretty much create anything. And because I'm using gRPC service 4, I'm going to copy this and make this into a client. Okay. And there's one more thing that I want to do, because by default it gives me NET Core 3.1. I'm going to change that. Right. So now I have this gRPC client. What I'm going to do is I want to reference this, right? So there are multiple ways to do that is like telling the client to actually basically, build my service client from a proto file. So I can actually point it to this proto file. So I'm going to add service ref. I'm going to right click on the project and say add service reference. So add service reference. Right now here, and now I'm going to say gRPC. By the way, you can do this for even the open API like the Swagger. Like as long as there's a Swagger definition, it can also create a client for you from that. So right now this is gRPC. So here's file. So if I have a URL, a general one of the things that we do that in eShop and containers is basically we also expose proto file as a endpoint. Like you hit /proto and it gives you the proto file. That's a good way to actually expose it as well so that you know what contract you want to work with. But in this case, I'm going to use the file. So I'm just going to navigate to the gRPC service 4, protos, greet.proto, open. And then now I want to choose what am I generating. I'm actually generating a client. So from this proto file, I want to define a client from it, right? So I click on finish. So what's going to do is it's going to install the necessary NuGet packages. And my gRPC client is ready. So here's the proto file, and if you go to the program.cs, now actually add in code to work with it, right? So I'm going to dump in some code here, and then I'll start explaining things for you. Okay, so I just changed the main method. Now you can see that there's gRPC channel. So I need the gRPC net client. And you can see greeter. What is greeter, right? So if you go into the definition of it, and this is what I wanted to show you, this is an auto-generated code. So from the protobuf file, we actually created a client code for you. And that's why, and this is a generated code, so you don't have to worry anything about it. Don't go and edit it. It gets regenerated whenever you just basically go and change the proto file, right? So that becomes easy. Now, when you're actually connecting, it has this method. So if you go to the greet.proto, it has this method called say hello, which accepts hello request, and it responds with a hello reply. So these are hello request and hello response, right? This is defined to us by the service. So when we created the client, it automatically knows you're actually connecting. You want to connect because basically it's a method. So it becomes a method, right? And then you have the channel. You basically say what channel. In this case, I'm hard coding it to 5001 because we are running it. Otherwise, you can actually run it from the configuration, or you can inject it during your CI process and that kind of things. So you have the greeter client, say hello async, and now it takes a parameter, which is the hello request. So we're actually defining it. And now we basically want to go to console.writeLine and response message. Now, what exactly is response message? And that's why we want to go back to the services, go to the greeter service here. So this is what it does. Basically, it takes the request and it just adds hello to that request. That's all it does, right? So now you can see that, how I'm pretty sure if you're coming from the WCF world, it will look very, very familiar to you. But WCF was very specific to Windows, but gRPC is not. gRPC is cross-platform, and that's why if you have applications running on WCF, we've written a specific book on how to port your WCF application to gRPC. So I encourage you to go and check that out. All right, so now this is all working. So let's run this. I hope it's working. We build a client. Okay, service client. Start new instance. Going back to the Solution Explorer and debug, start new instance. And you can see that it basically responded to the request. So if I go back to the client, okay, it basically stopped because we didn't put a read line or something like that so that we can see the output. So let's go back to the program. Let's see, where was it? This one. So let's put a console.read line here. So now we'll run it again. Start new instance and debug. Start new instance. Okay, now when it's running, it's going to actually connect with the backend code. Because the target machine actually refused it. That's funny. Why is that? Okay, that's probably because it was using the port. Let's see. Or did I make any mistake? I think I made some mistake. Hang on, let's see. What? Okay, looks fine to me. Okay, let's put a breakpoint here. Let's see what happens here. And okay, there you go. Response hello.NET Conf. So that's working fine. Cool. So you got the message, right? So how do you build gRPC, the great tooling support that you have? So let's switch gears and we'll talk about TIE now. So, when you build microservices, you're technically not working with single services, right? That's where we're going to the next step, which is when you want to work with multiple services. So let me go back. I have this the code which has a backend and front end. So if I want to basically have a backend, which is nothing but this weather API, and I also built a front end for it so that it connects and shows those displays those things, right? So if I want to run this, I can go to cd backend .NET run, which is what is going to happen now, and I will open another page. So in that tab, go to the front end, and then just say .NET run. They both will be running. So this is running on Finance 0, 00 and 01 port. So front end, that's what I'm concerned about. So let's go to the Finance 03. So I'm just going to copy this, go to my browser, put that in. Oh, there you go. So we have the front end page. I go refresh. So every time I hit refresh, you can see that how it's going and connecting to the backend and getting the data from the backend services, right? So that's the same weather forecast that you saw. And it's just putting a nice UI to it. Fine. But wouldn't it be nice, instead of doing this, like multiple .NET runs, and like you saw that I was doing start debug instance with gRPC and other things, like, when you have multiple microservices, it's going to be extremely difficult to work with. So we built a tool called TIE. And TIE is amazing because it ties things together. So all that I need to do is, let me clear this page. So this is my backend and front end. I have a solution file. So I can just say TIE run. That's all you need to do, right? So it just goes and actually looks at your solution file and then actually finds CS projects and it's going to run it for you. And it also gives you this nice dashboard. When we talk about microservices, it's all about amazing dashboards, right? So we get this nice dashboard with, if I just make this bigger slightly, or so you have the logs. So you can see that, if you go to the front end, it'll also gives you the metric, what's your .NET code looks like. It'll also give you logs, like when it started. These are the logs that has now, and it also gives you URLs. Now you see that it's no more the Finance 01 or Finance 02 that we created. It's actually a completely different one. That's because TIE is looking at your port in your system and giving you a port that is available to you, right? So now I can go and hit the front end application, and let's see what happens. There you go. It's errored out, right? Why is that? Because it's actually trying and looking for localhost Finance 01, which is no more available, right? So let's go and fix this. And you can easily fix this by stop hard coding, right? So let me open this. Okay. I'll open this code folder. And while I'm doing that, I can also do TIE run use watch, so that I don't have to redo this all the time. Okay, now I have the backend and front end. Remember, it was actually connecting to the front end, so you can go and look at the place where actually it's hard coded. So here we go. So it's actually hard coded to Finance 01. So I'm going to comment this out and then uncomment something called as configuration.getServiceURI backend. Now, what is this backend? Remember when we went back to the dashboard, which I'm going to open this here again. So this service name that you have by default, actually TIE is using your CS project name. So that's what you need to define. So that's why it says backend, right? To enable this get service URI method, which is an extension method, you will also need another thing in the CS file, which is Microsoft TIE extensions.configuration, and that will ensure that it'll pick up the right value from your configuration of TIE, which we will see it in a bit. So I just saved that now. If I go to the TIE dashboard and then go back, and there you go, we are back in the application. It started building now, right? So we fixed the service discovery now. Now let's go and add a few things, right? Every single service out there will work with some data store. So in my case, I'm going to actually build a data store for this, which is a cache, Redis cache. Let's go and build a Redis cache. Now, if I want to start building Redis cache, how am I going to do that? Do I install Redis? Go to Redis and download and install Redis? You don't have to, because you can actually also work with Docker. You can work with Redis containers, right? So that's what I'm going to do. But for that, I need to tell TIE that I need Redis, right? How do I define that? So all that you need to do is use TIE and then use this command called TIE init. You can actually very well do this much before. What this is going to do is actually going to give this YAML file, which is the configuration type. So by default, this was given to you when you're doing TIE run. It was looking at SLN file and it knows what CS process to run. It was doing that. But now we're actually declaring it explicitly, saying what services that we want to work with, right? So now I'm going to copy and paste some code because we want to work with Redis. So let me just quickly go into my notes here. So I'm going to add this. This is all I'm saying is it's going to be Redis, and you see it's no more a CS proj. It's not. I'm not saying project. It's now I'm going to say I need an image called Redis, and what port do I want to run on? 6379. That's all, and then the CLI for some debugging purposes. So let me leave that there. And how we're going to connect to is basically host name and the port name. What will happen is Redis :6379 will be your endpoint that your applications get to connect to. Now, when you're running it, when the Docker image is running, you can actually say Redis :6379, and you'll be able to connect to Redis. Now, what I'm doing is I'm actually implementing this in my backend. So if we go into my startup.cs, so you can see that right now I'm picking the connection string from Redis. So I do have this thing written already, add stack exchange Redis cache. So this is what you would be using if you want to use Redis with .NET. For that, you also need a NuGet package called Microsoft Extensions Caching.stack exchange Redis. So you can use that. And I'm also going to implement this, right? So instead of actually having this random get string that gets generated, I'm going to stop this. Comment this. I'm going to have a new method. So you can see that this is my new method. So this is another demo. We'll keep this commented for now. This is the same get method, but I'm actually taking the cache implementation into it. So because we added the add Redis stack cache, we will also populate this iDistributed cache to be Redis cache, right? So now what it does is it creates a caching technique where for 5 seconds, it's going to keep the cache, and after 5 seconds, the cache will be expired, and it'll just go and just generate this random number again. Great, right? That's all I need to do. And let's hope this all works. So I go back to TIE, say TIE run. So now when it's running, you might as well see that it's actually also pulling the image called Redis. So let me show you this here. Go back to the dashboard. Dashboard here, refresh this. So you can see that now, not just TIE build the backend and front end, but it also pulled the Redis. But look at this, Redis is basically a container. So it's running inside a container. So it knows how you need to connect to this. So this is the port that is exposed. Now, if you go to this application, as long as you write up the code correctly, so you can see that now it directly works with the Redis. So wasn't it easy doing that? So basically, TIE makes development easy with whenever you're starting with microservices, because you will have a bunch of microservices that you have to work with. All that you need to do is just TIE run and define in TIE YAML, right? So let's do one more thing on this TIE YAML, right? We'll go and add something called an extension. So let's say if I want to work with some extensions like Zipkin for distributed tracing. I want to understand how my applications is working with each other because it's all service to service communication. So I want to see how that is working. So I can actually go here and add extensions. And I'm going to add name. And I'm just going to say a Zipkin. That's all. Okay. Let's see if this is going to work, because sometimes there could be the YAML, if you don't do it properly, it can actually create mess. Okay, so you can see that there's Zipkin also has been pulled, which is great. And let's go back to the dashboard here, refresh this page. There you go. There's Zipkin as well, right? Which was very cool. So now if I just go to the Zipkins endpoint 9411 by default, run query, you can see how our application is running, right? So it can also show you how long does it take. Front end has connected to back end. You can see this information, which is very, very useful. And we didn't do anything. We just added Zipkin to it. There's one more thing, by the way. If you want to enable Zipkin, we also have to enable open tracing in .NET. And the way you do that is basically go back to your code, and I'll show you quickly. The program.cs, yeah, this is the code. You have to set the default ID format to the W3C. That's all you need to do. You need to know, and rest of all is taken care for you. So Zipkin, when there's Zipkin measured, it will basically send those values into Zipkin. All right. So that was easy. So we did that too. So how much time do we have? We do have 10 minutes. And do we have any more questions?
Yes, we have two questions. So
Sure.
One is from earlier. So Krunal is asking how data is shared between microservices when you have a separate database for each service.
Yeah. It is, again, using databases. Data is not shared. It basically one service is querying the data to the another. So you can actually, one service can connect to the other service and ask for the data, what it needs to process it. So that's how you work. You don't share data. You will never share databases. So that's the key thing. So the way to do that is two things. We have endpoints. So you can use synchronous call. So for example, when the basket is you're making an order, and from the basket, you basically can tell order, hey, here is the data that I need to process it. So give me this information. Or you can actually synchronously send, in case of, for example, when the order is placed, the order can actually say, basket, hey, basket, this order has been placed, just remove it from your basket. And basket will go and do the removal thing. So that is how it works. And you won't share the data between the services. Sometimes you probably want to keep the data, like for example, a search service, right? So a searching service will have to work with multiple services to get these queries. So instead, it can also keep a materialized data, like a materialized view pattern, right? So where you have all the data, CQRS basically. So you basically create all the data that is needed for your service, which you don't have to query. You can keep it in your databases. That means it's a duplication of data, and which is totally okay, because from the distributed computing world, it's about availability of data. It is so you should always have the data, so you're not worried about the network and the breaking kind of things. You basically have the local data, and you will figure a way to actually synchronize that data. Either when that data has been added or updated, you send an event, so the search also can update it at the same time, or search can do a polling and pull the data from the other services in a periodic phase. So those kind of implementation is up to you. Okay, I hope I answered that question.
Yes, okay, so we have another one from Jason. Do we need to include TIE in production build as well?
No. So the thing is, TIE is basically it is going to make your development easy. So TIE is basically simply a tool that is installed on a developer machine, which makes easier to build. TIE has this deploy option. So when you say TIE, which I think I can show you in a bit, TIE deploy, and it can actually deploy to Kubernetes and install everything that is needed. So whatever you define in TIE YAML, it's very similar to if you have worked with Docker Compose. right? So you will define these services, and then you do Docker compose up, everything comes up, all the Docker images get pulled and works. Similarly, in Thai, as a .NET developer, I didn't even create a Docker file in this case. If you don't notice, like I don't have Docker file in my thing, right? It is still running as a container. It's creating the network for you. It can also work with the image that you define it. So it creates that space for you. So when it comes to production, ideally, every service will have its own CI/CD pipeline. So that could be completely different from Thai. You can still, if it's a small project, something, you still can use Thai, deploy, and then deploy to production, because Thai has that option to do that. But I would suggest, if you're like a really large large company with hundreds of microservices, that's when the microservices will make sense. You would have an individual CI/CD pipeline which will take care of that. Good question, Jason. I guess no other question right now. Okay. So let's get back. So since I answered the question to Jason on Thai with production, I want to show you one more thing, which is basically deploying, right? So I can go, if I want to deploy this, all that I need to do is get my kubectl, which is Kubernetes. By the way, if you're working with Docker, here are some tips and tricks. You can use Kubernetes that comes from Docker itself, which is what I've been using. It's great for local testing, deployment. It's a single node thing, so it just works straightforward. Another thing about Docker, use this thing. Use WSL2 base engine. So install WSL2 and then make sure enable that. So that way, I basically don't have a VM and a kind of thing set up because it's running on WSL2. So that's also a simple trick. All right, since I have this Kubernetes configured, so let's say config, what are the available options? Config get context. This is my Docker desktop that's running. So this is where my Kubernetes config is. So once we define that, you can actually, from the folder where you have the Thai YAML, you can actually say Thai deploy interactive, and then go back and then hit enter, and you can go define the services. So this will take some time. What it does is basically creates an image. Like you didn't even specify a Docker file, but it looks at your CS proj and creates the right Docker file for you, and then it creates the image and push it. So right now I do have it, and by default it deploys to the Kubernetes thing. So now if you see, I have already installed in my Kubernetes, and you can see that there is backend and front end and other things. So I can basically, let's do this. Port forward, service to front end, and I will expose 3080. So now if I go and open my browser, which there are so many, localhost 3000, you can see that there is some application which is actually running there inside Kubernetes, right? This is cool. So I can refresh it. Like you can see that caching is working. Everything is seamless, right? So I can do that Thai deploy as well. Now, while doing this, there's another thing that I wanted to show you, depending on how much time we have. Think about 6-7 minutes. So like, resiliency. I want to talk about resiliency a little bit, because when you're doing service-to-service communication, let's go back to this architecture document a little bit. Let's go to this GitHub. Yes. So when you have this service-to-service communication, right? So you can see the database is separate. So when you're connecting with the multiple services, there are chances like you will connect with multiple services. Maybe you're connecting to catalog, and catalog is actually fetching the data. Sorry, if you're connecting to basket, basket is fetching the data from catalog. It could be a synchronous call, and something goes wrong in catalog, it can actually create a cascading failure down the scale, right? Why do I say that? Is because, in terms of Kubernetes world and other things, there could be chances for Kubernetes trying to change your images, pulling something new, you are actually updating in the production, something can intermittently fail. In such cases, your code has to be very smart enough to handle resiliency. And the way you can do that is basically implementing two patterns. One is the retry pattern and the circuit breaker. I'll quickly show you if I can show you that in the code first. So go to the controller and let's create this error. So I'm just going to create this error for now. So this is my random value whenever this exception, just creating this, right? This is not in real time. You won't do that. So when you do that, let's do a try run here. Okay, sorry. Wait. Run. So we just created the error, which means if I go back to my port and on the front end, it's working now. But sometimes you can see that there is an error, but if you refresh again, it will go. So it's a very random error, right? So in such cases, it's a good pattern to implement to handle resiliency. So how do you do that? There are two ways to do that. One is you can actually directly write this code right into the code. For example, in my case, I'm actually connecting with the weather controller. So here, this is my front-end code, which is actually working with the backend. So wherever you're connecting, you basically can add policy. Now, this is available to you because using using Poly, this is a library that gives you in .NET where you can actually add resiliency directly into your HTTP client using iHTTP Client Factory. So I'm going to enable this. So what it is doing is within this code, you have this HTTP poly extensions that handle transient HTTP error, and it is going to do simply retry, and it's going to do an exponential retry, which means like you make a connection, it is failing, so the next connection may not be almost immediate, because if you do that, then there could be DOS, denial of service. So we don't want that. So you want to wait for some time and then connect. So when you do that, what happens is the calling code will not fail because it's still waiting on the response. So we can magically make that error go away. So I just enable that. Now let's, I should start using Thai Watch. I've been doing that. So come on, Thai. So now if I go back to my dashboard, refresh this and go to this page and refresh it multiple times, you can see what is happening is it'll never fail, or it'll never show the failure. It is actually failing behind the scenes, because if you go to the logs, what it is doing is basically it's waiting and retrying, and that's what it does. So the other pattern that you can use is basically a circuit breaker, which is basically, like a circuit, there's an open circuit and closed circuit concept. So whenever there is an open circuit, there's no more connections made. That means there will not be any calls made. When the circuit is closed, which means the connections will be made. So you can decide after how many tries do you want to keep the circuit open for how long. So that way you don't keep hitting it and kind of handle this thing. So you can see that these kind of code is basically written right inside your business logic now. Like this is your service, this is where you're writing it. Another way to do that is basically using a service mesh. So in my case, I have the Linkerd installed, and let me show you this. Because I only have 2 minutes and I can take questions meanwhile. So I encourage you to go check this code out. I actually have written this. So if you go to github.com/channel, that's my handle, GitHub, Twitter, Instagram, wherever you want to follow me. So there's a thing called on.net, and I actually showed this in the on.net show. So here, it's the same code that I'm showing you right now. Within the main README, I basically tell you how to do this. Like, this is the way to do it in code. But you don't have to do it in code. It's better to do it in the infrastructure, because you can handle resiliency in infrastructure. The advantage of infrastructure resiliency is that you're avoiding all these kind of cross-cutting code from your business logic, and you're actually focusing on your business logic, and let let something like a service mesh handle for it. What does service mesh do? It basically attaches another pod within along with your service, and it will take care of all the networking for you, right? So it'll do all the networking and things. So it'll also gives you some nice monitoring tools, like in case of Linkerd, I'm using Grafana and other things. So this will give you all the information here. How do you do tie deploy and other things? So here you go. So you do a Linkerd check pre once you install the Linkerd. Do that to check if your Kubernetes is capable of doing it. Like if you're working on the latest Kubernetes and other things, it's going to just straightforward work. And then you do a Linkerd install onto your cluster where you want to install the service mesh, right? So once you install that, you can go to the dashboard and see. You also what you need to do is, because I deployed it using Thai, I did not have any Kubernetes files available to me to edit and all kind of things. So I can use some commands like this, like, Kubernetes get deploy, get me the deployment of front end, whatever Thai deployed, give me the output in YAML, and I'll ask Linkerd, I'll just pipe that thing to Linkerd inject. And so what Linkerd will do is it will actually annotate inside your deployment file of front end, back end, and Zipkin in this case, and then it'll reapply into the Kubernetes. So what happens is you're taking your service mesh. So let me quickly maybe show you this. I have this dashboard. What it does is basically, so this is the dashboard. So you can see there's something called as meshed. So if you don't mesh, if you don't apply that command in this meshed, it would not be. So you can, it's again a opt-in feature. So you can decide, do you want to mesh, what other systems do you want to mesh, right? You can choose those things. So here, if you go into my Grafana dashboard, like for example, in my case, I don't have anything right now. I can run it, but I think we'll run out of time. So I'm just going to leave it. Okay, there's some from the previous runs. So you can see that, the success rate, like how are we working with and things like, so it gives you all these nice dashboards and things once you install it. And it now will watch how it's working with, like, you may not need Zipkin anymore. Yeah, you have those distributed tracing enabled, so these tracings will also pop up in your other dashboards like Prometheus and Grafana as well. Okay, so that's yeah, one more thing that you need to do is, if I go to Linkerd, so this is what I was planning to show, but since we are running out of time, just leave that. So you can actually enable this is retriable equals true, retry budget, retry ratio. Once you set this up, service mesh will take care of doing the retries, and you don't have to write that poly code at all. So yeah, few things like that. There's so many things in the cloud native world. So if you simply go to landscape.cncf.io, you'll see that so many things, so many tools and things like available. And this is what we do. We kind of like, look at this, we explore this, we work with customers, understanding how they are using it, and then we bring that into the documentation that you see here. So I will encourage you to go check that out. So if you have any questions, I can take that up now.
Yes, there is one question from Vivek. Shouldn't API gateway be connected to some service discovery rather than directly communicating to microservice?
Yeah, so it is basically in a service discovery, we are making use of the Kubernetes service discovery itself, because we configure that while we deploy it. So we pick it up from that. If you want to use something like console and other things, you could do that too. Like, it's again up to you if you want to, but we don't need any other features from it. So we were straightforward in working with those microservices, and it is still configurable in a lot of ways. So we are good with that.
Hey Nish.
Yeah. Hey, Mo,
So
tell me.
yeah, there is a couple of questions. So one is from Carl. Is it considered stable enough to start big project on it?
I guess the question is for Thai.
Yeah, Thai.
Yeah, it is. I mean, it's it's into your developer tools, so it has nothing. It's not going to bother any of your production scenarios. I would encourage you to start it and give us feedback so that we can make this tool better, because it just works. I mean, I've been using it for a couple of months now, like from the beginning of Thai, and it has improved a lot. And we are actually listening to feedback to see how can we make this better, because in microservices world, there's like hundreds and thousands of services, and you may not be working with everything at a time in your developer machines. So we want to understand what's your scenario like and how can we help. So if you look at what happened with Thai is I don't have Docker files. I'm not working with Docker Compose files. It's just straightforward. As a .NET developer, we wanted to focus on your business logic, your .NET core, rather than looking at infrastructure and that kind of thing. So I would encourage you to start looking at it. It's still in the preview and stages. We would see how this thing goes up till .NET 6, and that's probably the time we will make it like a GA. But I don't think you should need to wait for that because this is additional tool. It doesn't affect you in any way.
So this is a previous question from Jason. What is the
Yeah.
recommended way of managing transactions across microservices in .NET?
Yeah. So there are multiple things like compensating transactions. So let me just find compensating transaction pattern. I think we have it here. You can actually use this. Basically, it's nothing but, okay, this is all explained here. So if you go to .NET, sorry, docs.microsoft.com, Azure architecture, and look at patterns, and then look at this. So basically what happens is like you basically start not a transaction scope kind of a thing, but you basically start a transaction in terms of like if something fails, you basically send a compensating transaction to roll back the previous thing. So those decisions that you can actually make yourself. And there are a few more things. Actually, you can go to the docs. There's another thing. Let's see if I can find that. Saga is another one. Oh, I'm just trying to find the Azure documentation. There you go. So this is another page. I think I'll do one thing right after this call. I'll ping you these URLs directly. So read about this, like how you can actually implement this, and yeah, that's a way to go.
All right. So that's all the questions we have from attendees. So I have a couple of questions
Sure.
for you, and maybe it will be helpful. So when will you decide whether microservice approach is best suited for a solution? So is it applicable for all, or is it only for a specific solutions or specific area?
Yeah, that's a very good question. I mean, yeah, just because you went and attended a microservices session does not mean that every next service that you start building is a microservice, right? So I think the most important aspect here is, the moment you say database per microservice, database is different for every service, it just blows away people's mind because the complexity that it is going to bring in, it's going to be huge. So unless you are a team that large size, and that independent teams can be spin out from that and ship multiple services at a time, that is the time when you want to stick up microservices. So complexity and scale and making use of cloud, those are the important aspects. If then, go ahead. Monolith is not bad. Monolith is not about old versus new. Like monolith versus microservice, people say like, okay, everything is now microservices. No, it's just an architectural design pattern. Just like how you would decide a particular design pattern, right? Every design pattern exists to solve a particular problem. So it's not that you jump into it and then just start using it everywhere, right? So as long as large services and you want to make use of the cloud, ship 100 times a day, you can do that. Now the other thing is, like, people get confused with Dockers and Kubernetes to be microservices. No, you can actually take a monolith application, you can containerize it, you can still ship it as monolith application, right? So you can still make use of Dockers and Kubernetes and that kind of things. But in microservices, large teams, large applications, large problems, then it will be the right time to do that.
Okay. So other thing is, what options we have in Azure for hosting microservices?
Say that again.
No, what are options are available in Azure for hosting microservices?
Yeah, there are many, and that's why we wrote a whole book about it, which is like architecting cloud native apps for Azure. So this book talks about what are the services on Azure that you can use, starting from Kubernetes, and we also talk about how we actually do the eShop and containers, like mapping those services directly to how we use API gateway, and so on, right? So I would yeah, it's a lot of things. So I would suggest you to. It's all well documented. Just go and check this out.
All right. Thank you, Nish, for that wonderful session. Hope it was useful. And I know you have some Learn modules also in Microsoft Learn side, so it will be on
Oh,
the
good.
microservice side.
Good. Yeah. Thank you so much for bringing this up. I should have told this. So this is something which I've been working on with Cam and Scott. aka.ms ASP.NET-microservices. Please bookmark this link. This is a great link for you to do hands-on and Azure without having Visual Studio, without having any IDEs installed. You can actually run this on iPad. So this is create and deploy. So there are like bunch of it. We are actually building a couple of more ones, so it is in the making. So we talk about how do you do how do you start with cloud native, right? Being, as you said, when do you decide, how do you decide microservices? So we show you this particular application where you get to build a new microservice called coupon and attach to this existing e-commerce site. So what are the things that is involved in it? How do you decide databases? All those things are actually here. It takes about 1 hour to finish this course. uh, all that you need is an Azure subscription. If you don't have it, just create one. It's free for 12 months. Take that plan, just learn. It's hands-on. We wrote this. You can actually completely type it inside your browser because we have the Azure CLI. We make use of it. A bunch of investments have gone into this, so please make use of this. So the thing that I talked about, resiliency, it's right here. You can actually create resiliency in not just in the sample app, but in the production app. Like, how do you do resiliency in a production app, right? So that's here. There's GitHub Actions. There is instrumentation, which is about logging and other things. There's also feature flags. How do you enable feature? Like, say you shipped a new feature, but you don't want to enable it yet. You want to enable it to certain people, right? You can do those things using Azure feature flags. So you have hands-on modules for all those things. So do check it out. A lot of people love this content. I encourage you to check it out and then give us a feedback on how can we improve this content. It's all free. So please make use of it.
All right. Thanks again, Nish, for your time.
Sure. Thank you so much. And I really appreciate it, Amal. Keep it going. And we should do more sessions. Thanks so much.
Definitely. Yeah. Catch you later.
Take care. Bye.
Yeah. All right. So let's move on to the second session. That's from me. And building dynamic website with Azure Static Web Apps. Let me share my screen first. All right. All right. I hope you can see my screen now. Okay. So let's get started. My name is Amaldev. I am a Microsoft MVP in developer technologies. I work for KPMG as an architect. I have a blog called techrepository.in where I blog about this and the things I was working on. And this is my Twitter handle where you can contact me for anything regarding the session or anything on Azure or .NET. So, So jumping into the topic we have today, right? Hosting static websites in Azure. So many of us, in some point of time, we should have hosted a simple HTML website uh, on a dedicated server on a web hosting service or on Azure. So it's a plain simple static HTML website where we don't need these high availability or high resources or these huge resources provided by these hosting providers or cloud providers itself, right? We just want to host a simple website and serve it to condense it. Assume that I am hosting an event and I need a website, so I will create a sample HTML website. I will host it somewhere and use it that for the duration of the event and just done with it, right? So in that case, I don't need these high fund features that are available from these providers. I just want to host these static sites somewhere. So in Azure, there are two options until now where we can do that. It's using one is using Azure Storage and another was using Azure App Service. All right. So in Azure Storage, what we are doing that we will create a storage account, and from that storage account we host our web application. So there is no other thing that was needed there. Just create a storage account, put your static files there, and host the website from there. And by the way, this was the cheapest option available in Azure for hosting a static website. So there are certain limitations there for static websites, like we cannot set a default document, we cannot set custom error pages, there is no option to say set some authorization or authorization, etc. So if you want just a place where you want to show the sites, show the simple HTML pages, this was a good enough solution. So the other option we had was in Azure is Azure App Service. This is a PaaS offering from Azure for hosting websites. It's basically primarily used by um, hosting dynamic websites, say the websites created in .NET or Java. Azure App Service is used. It provides you additional facilities like load balancing, automatic scaling, advanced authorization techniques, and all those stuff that you expect from a normal web server is available in Azure App Service. But for hosting our static website, these things are not needed, and it's also a costlier option. So until now, these two options were available in Azure to host these, but they have now introduced a new service called Azure Web Static Web Apps. It's still in preview. It's not available available in GA. It's still undergoing what you say, polishing the latest features and all. It will be soon available for public. The preview is available public, but the general availability will be soon later this year. So what it does is that it gives you the ability to automatically build and deploy to Azure directly from your GitHub repository. Okay, so it supports modern frameworks such as Vue.js. Sorry, there's a typo there. It's React.js, Angular, Blazor, and more. All these modern full stack frameworks based on JavaScript are supported in Azure Static Web Apps. So not only plain static HTML websites, so the sites developed using Angular and all this stuff are supported. And so there is one more additional functionality which the static web app supports is the backend API support. So sometimes when you create a sub website, right, say an event website, in that case, you will have a list of speakers or the event schedules or the session agenda that needs to be created or fetched dynamically from a backend data store. In that case, what we can use is that we can make use of the backend API support provided by static web apps to interact with a Cosmos DB or a flat file. You can go and fetch the data from there, return that back to your static application, and show it there. So thereby, we can have some sort of dynamic nature. We can add some sort of dynamic nature to these kind of static web applications, which is not possible if you are going with an Azure storage option. In Azure App Service, it is possible, but again, that is a costlier option. So again, other it also supports static site generators like Jekyll, Gatsby, Hugo, and ViewPress. So if you are using any of these, you can host your applications in Azure Static Web Apps too. So what all the features it have? It has a first class web GitHub integration. So at this stage only GitHub is not GitHub is supported, not other source providers like Azure DevOps, and only GitHub is supported. So what it internally does is that it internally uses Azure CDN to host your static content. So that means the content is available nearer to the person who are browsing or who are using your sites, and that is done automatically by Azure. So it globally distributed the content using the Azure CDN. So even though you are not specifying that explicitly while creating the website, it is managed automatically by Azure. It also provides free SSL certificates, custom domains. So you have a different domain, or you have a top level domain and you want to use that, you can do that using Azure Static Web Apps. There is no restriction such as you will need to use only the URL provided by Azure. And also it supports, it also gives you a staging environment where you can stage your changes, preview your features, and after that, once you're satisfied with the changes, all changes you are made in your code, you can automatically promote that to a production environment. The other feature, it also support authentication providers like Azure AD, Facebook, Twitter. You can implement that also too. And also, if you want to have some sort of authorization to handle the content, or restrict the content to a specific type of users, you can use that using customizable authorization definitions. And also you can provide backend routing rules also. So if you want to have a specific URL that needs to be shown in your address bar and serve a different page, you can create your own routing rules and use that to serve your content. So basically, this is the flow for an Azure Static Web App, where what we'll need to create a repository in GitHub, and you will clone that repository in your local machine. You work on your code changes, then after you push or create a pull request to the repository. The Azure when you create an Azure Static Web App, what happens is that it will automatically create a GitHub action in your repository. GitHub actions are workflows available in GitHub, which can do a set of jobs automatically for you in a specified manner. So when you create a static web app and hook your GitHub repository, it will automatically create a GitHub actions, and using that GitHub actions, it will build and deploy your code to Azure. So again, there is no need for you to create the actions itself. It will create it automatically for you, but you will have the option to edit the actions from GitHub. And then it gets deployed to Azure Static Web Apps. And so suppose if you have your front end part in Angular or Vue or Vue, it will be deployed into that particular directory. And if you have a backend function, Azure functions, it will be deployed separately. And the communication that is going to happen between your front end and backend is automatically handled by Azure. There is no need, all the cores and all are automatically handled. There is no need for you to separately host these two parts. It will be done automatically when you do the deployment. So let's switch from our slides and see how that can be done. So let me go back. So here I have already created a web repository in my GitHub account called Static Web App Demo. It's nothing in there, and I have already cloned the repository here in my local. So what I have done here is I have a static website, source code for static website is available here. So it is basically an event website template. So let me browse that solution and show. It's like a simple website where it has got a content, where it has a speaker section, it has an event schedule section. All of them are static site, all are static content. You can see here all are specified in this HTML code, and it is being served to the browser. So let's see how we can create a Azure static web app in Azure and then push these changes from my local box into the GitHub repository and how it is automatically deployed in Azure. So let me go to my portal. So if you are new to portal, you can just search for here Azure static web apps. Azure is not static web apps, it's in preview, it will show here. So you can click on add here. So first, for every resource you need create in Azure, you need to create a Azure resource group, or you need to have a resource group. I have already one created already, so I will provide a name for my web app. I will say the region. So as of now, only free SKU is available since it's in preview, and so whatever you create, it is free of charge. Only the storage account you will be charged only for the storage account only, and when it nears the general availability, you will get more SKUs and more uh, enhanced hosting options. Okay, so this is for the website. Now I need to hook my GitHub repository to this particular web app. So you can go and sign in with GitHub here. You can authorize the application. Okay, now what it does is that it gets all your information from GitHub. You can select the repository you want to host here. It's not .NET Foundation. I'll choose the branch, and if you scroll down below, it will have a build details section. This is where I will specify what type of application is I am going to host. So if you are a Angular or a React or a Blazor application, you can choose that, and it will give you appropriate option for that, where is your as artifacts folder and all those stuff you need to specify there. So since I am using a plain simple HTML website, I'm not going to create anything. I will just go and say review and create. So please take a note that this particular repository only has a git ignore file, right? So I'm now going to create my static web application. Now my web app is created. So it will, if I go back to the repository, you can see that it has automatically created the GitHub actions. So if you go to the actions tab, so it has created an action and it is already running a GitHub action. So since there is nothing, if you go and browse the site, it will say that your static web app is live because the repository is empty, right? So let's go back to our repository folder. Let me add this. Okay. All right, so all my static pages are now available in my repository. So if I go back to my actions tab, I can see that it has already started deploying, triggered the actions phase. The first step is for build and deploy the job. So what it does is, if you go there, it is going through all the steps defined there. It is going to my repository. It is getting all my latest files from there. What basically it does is that it creates a Docker image. It builds your application and then runs that application for you using that image. All right. So let's give some time. All right. So it has now completed the deployment. So if I go back here, you can see that my static website is now hosted in Azure. This is the domain subdomain it created under Azure App Static Apps.net. If you have a different or if you have a custom domain, you can go here to custom domains. You can add the CNAME record under with your DNS provider, and then it will use your top level or your subdomain for accessing the website. So you can specify that here. All right. So that was a basic quick demo on how to create an Azure Static Web App Service, how to push the repository into static service, and how it is hosted in the Azure Cloud. So, any questions you have until now? All right. So let's move. So
Yeah, we have one question. Just
yep.
yeah, from Jason. So under the hood, static web app is just storage of the static content.
No, I can say it's not only a storage. It have this additional functionality to implement the authentication and authorization, and it also implements a backend API. Internally, it creates Azure functions for that, and it hosts that functions, and it handles that communication from your front end to the back end, and it's not only specific storage counter. It do some additional sort of things too.
Okay, we got another one. So from Fansalot, can I use DAI to create mixed service, including this is for the
Maybe
previous
yeah, maybe
presentation? Yeah.
for niche. Okay,
Yeah.
I
Yeah.
can
Okay.
get that info from niche
Mhm.
and will respond back.
Okay.
Okay. So what? Let's move on. Let's move. Continue with our demo. What I'm going to do is now. Suppose if I go to this site and I'm typing in some invalid URL, it is showing me a custom generic static 404. Now I need to override this with my own. I need to have a custom error page which is in line with my design language of the site. So what I can do is that for that I can create a files called routes.json. Okay, this should be, if you are hosting a static website, this should be in your root folder. Okay, so now let me create an entry. So over here I provide a platform override section where I will specify the error page that needs to be served in the case of a not found error, in the case of an authenticated unauthenticated error is happening in my website. I need to I am telling that you need to serve this particular page. So for 404, I'm saying that you need to serve this custom 404. For that, I will need to create a new file called custom 404 HTML. Let me grab that file from which I already created. All right, so now let me push these changes. Okay, I'll do that from all right. So what I'm going to do is I now okay, let me do one more thing. Okay, let me continue with pushing these changes and I'll show you the staging part after this. So maybe it will take a couple of minutes to the build part. In the meantime, if there are any questions, I can take that. All right, so let me go back to the static web apps and I'll show you the environment. So if you go to the environment section, you can see that there are two sections here. One is for production and one is for staging. So the production slot will have our latest running website that is serving to the users. It will be automatically deployed to this particular slot. Uh, what we can do is that we can have a staging section and we can actually create a pull request in GitHub repository. When you do that, it will automatically deploy this staging environment where you will be able to browse that website. In that staging environment, you can see how it actually looks in your Azure App Service, and you can go through the changes. Once you are satisfied with that, you will go to GitHub, you will merge your changes, then it will automatically push from staging to the production environment. So let me see if that's completed. Yeah, that's completed here. So let me go back to my site and if I go here, you can see that it is serving the custom HTML page I defined, and it is not showing the generic page provided by Azure. So how this happened is because of this. I had this platform override here specified here. So let's do one more change. Let's create a new page here. Okay, I will go to a new branch, dev, create a new file called schedule.html. Let me grab that file from here. So what I have done is I created a new file called schedule, which is basically a subset of our event website, which will have only the event schedule part. Okay, so now what I'm doing is that I am directly taking the website from my web application. So we will see how we can define the routes in our route.json. So I don't want to show the entire file name in the URL. I just want to show the schedules. Okay, so what I can do is that I can create a route in my route.json. So here what I am specifying, there is a route array. Inside that route array, I am specifying the rules. So if I am typing in /schedule, maybe I can specify that if the URL, if the route is event schedule, then you need to serve the schedule.html page to the browser. So I can stage my changes. So let me create a pull request. So I am using a pull request extension provided by GitHub for Visual Studio Code. I can go here, create a pull request. I can choose the target branch. I can choose the local branch. To show what should be the message, I take that from the latest commit message. So now I have created a pull request. So if you go back to the portal, go back to GitHub Actions, GitHub portal. If you refresh our environments, you will see once this build is completed, you will see that it will get deployed to your staging environment. Okay, so you can see now, right, there are two versions of my site. The main branch is having the latest production version, whereas the staging environment is running from my dev branch, which will has the latest changes. So if you go to this browse, you can see that the URL itself is different. Right, one for again, this is automatically created by the uh, Azure website only. So if I say here event schedule, it will show you the latest changes I made to my dev branch. So if I go back and if I take my production site and if I paste the same URL, it will say that for node 4, because in the production environment there is no route specified. That's why. So what we can do is that let's merge that pull request so that so when you create the merge, it will again automatically do a build, and it will, what it does is that once the build is completed, it will go here, it will come here, and it will remove this from the staging environment, and whatever changes was there, it will be promoted to a production environment. All right, so let's go back to our slide. And in the next section, I am going to show you how you can implement a backend API support for your web application. As I said earlier, take the case of an event website where I need to have the speaker and event schedule section fetched dynamically from a backend store. So I will show you how you can do that in Azure Web Statics Preview. Okay, so the backend API support is provided in Azure Static Web Apps using Azure Functions. So you need to create Azure Functions for implementing your backend API logic. For creating the Azure Functions, you can do that in C#, Python, or Node.js as of now. All right. All these Azure functions will be implemented as HTTP triggers with input and output binding. That means these functions can accept input from the front end, and it can return the values back to the front end applications. So one restriction we have right now is that all the functions you define or you create should be routed under the prefix called API. You can't give any other prefix for doing that as of now. And for doing your logging in your backend API functions, only application insights are supported. So if you want to log that to a file in your storage account or somewhere else, that is now not possible. It will be coming when it nears the general availability. As of now, only app insights are supported. So this is with the route.json. In the prior demo, I showed you how you can define routes in your routes.json file. So it is executed in the order as is defined in that particular array. So if a match is found for at the first instance or at the first element itself, it won't execute the rest of the things. It will return from that and it will serve that route. And the location of the route.json file is different for different frameworks. So in Angular, it should be under the assets folder. For React as well, it should be under public. For Blazor, it should be under www.root. Okay, so for Blazor or static HTML pages, it should be under www.root. So as we saw in the demo, you can specify the route, you can specify the content that needs to be served for this particular route, what should be the status code that needs to be returned. So if you're having some endpoints for your API, you need to return a different static code, then you can specify that. And also if you say implement RPC or role-based authentication for your routes, then you can do that. You can specify the role names and all those stuff, and you will implement the custom authorization logic to handle that. So you can specify that too in your routing array. Again, for authentication and authorization, you can make use of these third-party providers for authentication, like Active Directory, GitHub, Facebook, Google, and Twitter as supported as of now. And for authorization, there are two methods. One is anonymous, so that means everyone can access everything, and there is an authenticated method. So when you implement authenticated authorization, then it will only allow the users who are authenticated by using any of these third-party providers. So this is your typical routes.json route file looks like, with all the options which I have mentioned. So let me again go back to the demo. So what I am going to do is, now I am going to create a new static web application for an Angular application. So I'll go here, I'll click on add, I'll select the resource group, I'll give a name, choose a region, I'll connect to GitHub. I have a repository already in there. So okay, main branch. So now what I am going to do is that I will say my framework is Angular. The moment you choose Angular, it will give you additional locations. So what should be the location? What should be your root folder? You can specify slash, or if it's residing in some folder under your root folder, you can specify the path here. This is the API location, and this is your artifact location. So by default, Angular creates the artifacts in the list directory, and it will create the Azure Static app based on these options. So I have the static app already for that. So this is an Angular application which I created. Okay, so if you go to here, functions here. Okay, so we'll do one thing. We'll push this here. Okay, so I have a function here already. I have the website here already. What I'm going to do is I'm going to push the sites here. Okay. All right. So this is my Angular application. I have promoted my static HTML content page into an Angular application, and I have created the necessary component and all those stuff. And also I created a couple of Azure functions called get schedule and get speaker. So what I'm doing here is that instead of using the static HTML content for showing my schedule and speakers, I am using this these function endpoints for the time being. So I have created an in-memory data store. I am when I call this get speakers function from my Angular application, it will come here. It will then return this content back to my application. So similarly for schedule, I have created a sample store and I'm returning that back to the API. Okay, so what I am doing here is that if you go back to my Angular application, go back to my component, the home component, you can see here for speakers I am making use of the app speakers component as well as for the schedule day one I am using the event schedule. Sorry, not here. All right, so I have added a link for event schedule page where it will be redirected to the schedule page and it will show the event schedule. So that is here in the speaker. You can see that here I am calling to the speaker service, which is the get speakers endpoint, which is defined in my service component, where I am using the HTTP client object to interact with my API. It will call the get speakers endpoint. It will get that information from there, and it will then return that response back to my front end application, and it will show it there rather than relying on my web application. So let me create a new web application here. So I will say that it will show you the GitHub Actions YAML file, what all steps it is going to do. You can preview that here. Okay, and you can go and review and create. Okay, now it has created. So build is going on right now. So any questions? Or are you clear about what I had shown until now? Or is it confusing? Any feedback? Or are you finding it useful? Okay, I'll wait, let it build. Still building. Let's give a couple of minutes. All right, now it's deployed. The application is there. Okay, now you can see that the functions we have the what all functions we have in my backend. It is listed here. The functions are automatically created by the app service. You don't need to manage anything. You just write code, check in your changes. It will automatically do that. Okay, now in my website, nothing is listing under my speaker section, or if I go to my event schedule page, nothing is coming, right? Let's see what is happening under the hood here. Okay, so why in the routes.json file, what I did is I set that. Okay. Let me go back to my repository and show that. All right, so what I said is that for the route, I said only the admin should be able to access, right? So since I am using an anonymous login to use my application, I am not able to, the API endpoints won't be hit, and that's why no data is coming here. So let's add an user who is authenticated. So what you can do is that under role management, you can click on this invite. You can specify the authentication provider. I can give my name. So I will say I will have this role, and you can also say set a expiration limit. You can set maximum is 168, that is 7 days. You can generate this invite link. I will get this invite. This expiration is only for this invite. The role assignment will be there. So it will generate an URL where you can go. You can send to the person who you are trying to add. I can use that. Since I have already granted the access earlier, it didn't ask me for username and password. Otherwise, when you click on that link, uh, cap it will ask you to enter your username, your password, and then a consent screen will come. And since I have now granted access to given the granted access, and since I have the admin role, the API, the call to the API will be honored. It will execute the API, and it will give back the data to the front end application. And you can see that now the data is populating because I given the access to this particular user, which is accessing the website right now. Suppose if you want to give a different role. You can assign that different, you can assign multiple roles for a user. Say you want to have a contribute, not the admin role, you want to have a contributor and a reader role, you can give it as a comma separated values. So whatever routes require these particular roles, it will be honored for that particular user. That's how we can handle authentication and authorization in the static websites. Okay, so that's pretty much the demos I had for this. So right now what you are seeing that I was using Visual Studio Code. I was using the command prompt to push that application, create the web app in Azure. I was going into the portal and I was creating the web apps manually, right? There are other ways you can do that. You can always use Azure CLI or Cloud Shell for creating your web application, Azure web apps. If not, if you want a integrated feeling, you want to create that right from your Visual Studio Code, you can install this particular extension in Visual Studio Code. Then you don't need to go out of Visual Studio Code for doing any of this. You can write that right inside Visual Studio Code itself, the publishing to the application, creating the websites, web apps, etc. in Azure. Everything can be done inside the Visual Studio itself by using this extension. These are some of the references where you can get started on creating your web application on GitHub Actions and all those stuff. Anyway, I'll be sharing this slide once the session is concluded, once the event is concluded. You can go through this to get started with Azure static web apps. All right, that's all I have. Any questions?
I think we don't have any questions for now.
Thank you then. So let me welcome Vishwanatha Swami for the next session. It's Vishwanatha Swami is a architect with AIS, and he will be walking you through sessions on building full stack application using gRPC, Web, Blazor, and Blazor WASM. Over to you, Swami, and good luck. Thank you.
Hey, thank you so much, Amal. And thank you guys for joining us. In this session today, we are going to discuss how can we create a full stack application in gRPC Web and Blazor WASM. So what do we do first? So let me share my screen real quick and we'll discuss on that. Let me set up the context. So if you can see this here, here is the code for this entire exercise, whatever we are working. So we'll be, I just mentioned the software tools and basic knowledge and assumptions and the technology stack we use. And what do we build today? So the thing is that we already have some of the common components. We'll be discussing about that. And we already have the web API. So we'll quickly test that. What does this web API do and how are we retrieving the content from SQL Server? And then we'll start creating the gRPC web. That's the step one. And we'll use two of those clients, Windows clients and console and Windows Forms client to retrieve the content from this gRPC service. And then we will go and create the Blazor WASM, and then we'll integrate this Blazor WASM UI with Web API as well as with the gRPC web. So that you know how can we integrate with the Web API and how can we integrate with gRPC web. So let's assume that we already have an existing microservice which is a Web API, and the new microservices are using gRPC web. So how can you integrate Blazor WASM, the single page application, with both these microservices? So communicating with REST Web API and communicating with gRPC web. Okay, that being said, so just give me one moment. Let me open up the okay, so let's go step by step on that. So let me give the URL also of the of this, so that you know you guys can keep it handy to try this after the session. You guys can try this. Okay, thanks. That's done. So let's start with this. My name is Vishwanath Swami. I work at Applied Information Sciences, and these are the prerequisites I mentioned. I'm working on OS, Windows 10 OS, .NET 5, and I'm working on Visual Studio 2019 Professional, but you can use Community also. So I'm using Postman, SQL Server, and Azure Data Studio, and this is one of the tool which I really like it very much. This we can use it to communicate with the SQL Server, maybe from within your anywhere, wherever you have the SQL Server, you can go ahead and communicate with that SQL Server. So we have a couple of tables here. Just let's have a quick glance of those tables. We have professors and students table. So I'm using, instead of SQL Server Management Studio, I'm using this. And this is a cross-platform tool also. I really like it very much. And that's one piece. And the next thing is I already provisioned all the scripts here. Under the scripts folder, you can find the creation of database and the tables and the data population, everything I just created. So you guys can go grab and create it. Okay, so let's start building this one. So what we already have, so we have this college core. So all the things which are common will be moved into this application core library. And what do we have here is we have one of this constant. So this constants file, and this is data store. I'm using this connection string, and for weather forecast Web API, this is one of the constants. I moved it to centralized location instead of spilling all over the solution. And there are a couple of entities. One of the entities professor, which is one-on-one map, which is one-on-one with this table over here. And other one is student, and that's also one-on-one map with this table. Okay, and we have a couple of interfaces. One is professor data access layer. So get all professors, get professor by ID. And we have professor business logic layer, that is get professors and get professors by ID. So that's related to the application core. And what do we have in the data access layer? Data access layer is a persistence, is one folder. It contains the simple DB context, and we are exposing 2 DB sets. So if you see the things on the left side, so that is coming from the entities folder. So these two are entities which are one-on-one map with these fields on the tables. And what are these on the right side of the DB set, the professors and students? That is the table name itself. If you see this table names, so the professors and students, it should have the exact spelling. If not, we'll get exception, right? So that's one thing. And in this professors DAL is where we are implementing those interfaces. where we retrieve all those professors for get all professors. Get professor by IDs, we are retrieving a particular professor ID. That's one different thing. So while we are here, quickly, I want to give one tip. So one of the tip is that we are doing the dependency injection. So the professor DAL depends upon the DB context as well as the logger. So we'll see in depth how does this dependency injection container gets loaded, how we get these dependencies in our code. We'll look into that in depth, but I just want to give a quick tip. So what if I add a new dependencies? Let's assume that I only have this one dependency, and suddenly I've added only the college DB context was one dependency. Now I want to add the logger also as part of my dependencies. So what I can do is I can very well do a copy paste of this and come here and modify this, and again go and do this one all, like logger equal to this logger, and do all these things. So we don't need to sweat at all. So whenever you are adding something new, you can remove the existing constructor and then do alt enter. So the moment you do alt enter, you will get this generate constructor, and just click on add null check, and then that's it. So you'll get a beautiful constructor. So whenever you have any constructor, assuming that you are not writing anything else apart from these kind of dependencies, you can do that. And if you have any other code apart from these dependencies, then please be little careful. So whatever I'm giving this tip is only when you are having only these kind of dependencies, you can auto generate. Alt enter, generate constructor. Okay. So that being said, let's go and see what is there in the business logic layer. Business logic layer is directly, it has got a dependency on the data access layer, and it's going to get the data from this data access layer, right? So let me quickly go and undo these changes, because I don't want to do any changes there. Okay, so that's the common libraries, whatever we have. And by doing that, what is the advantage of moving this code to respective libraries? The intention is these libraries should be part of the NuGet packages. Like if anyone else has got a similar functionality, most of the times what happen is the database will be common. Team A will be talking to one database, and team B will also be talking to the same database, might be with the same tables also. Like team A is pumping in the data and team B is utilizing it, and team 3 is writing. Like it could be multiple reasons. All and the entire organization might use it, or partially they might use it. So in that case, these are the right candidates to be as a NuGet package, because I don't want to reinvent the wheel. Someone would have already written this code. I just go grab it. So technically these are NuGet package, should be NuGet packages. Okay. Now if you see this, the web API, it is very, very slim. It doesn't worry about anything, because all those worries we have moved to those respective libraries. Now our web API is only focused on what should it expose. So it has got one controller, and this controller has got the two methods: get retrieves all the professors, and get professor by ID. So we have these two, and a couple of other tips in this while we are here. We are using this user secrets. So how do you go with the user secrets is right mouse click on this project, and you can add this user secrets, and once you add it, you click on this manage user secrets. We'll come back to that real quick. So if you see this app settings is we just mentioned that what all the information you want this to be in your app settings. So what happened is anyone who's using this project or is working on this project, he knows that what all the dependencies for this project to be executed. So we know that the connection string is here. This app settings is being checked into the source code repository, but we are not going to store, even if it is local or dev, QA, stage, prod, UAT, any environment. We are not going to store any credentials inside the app settings. All we have to do is, so that rest of the developers in our team or across team or the DevOps team, they know that what all the things which they have to provision. So how do you know that what are the connection strings which are coming in? You use this manage user secrets, and here this connection string is there. So even let it be my local or somewhere, whatever is the connection string, it is safe with me. So why do I say that it is safe is, let's assume that I am working on a production bug and I need to connect from this code when you're debugging, not production, maybe test or stage. I'm connecting from my source code over here, and I have the connection string of this. And the moment I fix the bug, I might check in the code with the credentials. So that will not be secret anymore. Now the entire world knows that now. Okay, so let's see that the dependencies we'll look into the dependencies once we come into the gRPC web. So or else while we are here also we can look into this dependencies. So here let's see that how does the dependency injection happens. Let me place the debugger over here inside the DB context, and I'll place another debugger inside the data access layer, and I'll place one more debugger inside the business logic layer. So the dependencies will get loaded. How it gets loaded, how it gets injected, we'll see that in a moment. So what happens is when the dependencies are there, so it goes and tries to create the instance of this, and it sees that it has got a dependency on professor BLL and logger. So then it comes to this professor BLL, tries to create this, and then it finds that it has got professor dal and logger. So then it goes to the professor dal. Then it finds the professor dal has got a dependency on the DB context and the logger. Then it goes here. Here it has got a parameterized constructor, but it doesn't have any dependency getting injected as part of the constructor. So it can create the college DB context. So in this way, what happens is the last man standing who doesn't have any dependency, that gets created, and it's been given to the DAL, and then business logic layer, then to the controller. So that's how. So what is this dependencies? Who holds all this? It's consider that it's like an ATM machine, your bank account, and your credit card. These are the three pieces. So you deposit money in your bank account, and you have an ATM card. You go and insert into any ATM and withdraw money. And if you don't have anything deposited into your account and you go and try to withdraw money, you'll get the transaction decline. Similarly, inside the startup, so one of the method what we have to focus is on the configure services. So this is the one which holds the service container. So all the dependencies, whichever we need it, or whichever are the application dependencies, we have to load it here. So if you see that the college DB context, the business logic layer, and the professor DAL are the application dependencies which we are loading. So one more question anyone might ask, hey Swami, you said that these are the application dependencies, but where is this iLogger coming from? Let's look at that in a moment. So some of the dependencies which comes out of the box, okay, some of the dependencies which is application dependent, we have to add it. Okay, let's click on execute, and let's see that how does this dependencies container gets loaded, and what all the dependencies which are coming out of the box. Okay, so this is the first one. It's hitting. So right mouse click on that and go to that quick watch, and you see that there are 79 dependencies. Now if I expand this result view over here, you can see that the iLogger, it's over here. So the iLogger is coming out of the box, whether you without doing anything, iLogger is coming as part of the dependencies. So there were 79, and I do I do 81 plus 3. It will add 3 dependencies on this. Let's go and do a quick watch. 81 plus 3 is 184. You can expand this view, and we can scroll down to check that our application dependencies are also loaded. You can see that the college DB context, these 3 dependencies are our application dependencies we just loaded. And after that, we are loading 2 more dependencies. Those dependencies are those dependencies are also our application dependencies. So one for the, so 181 plus 3, 184 plus 2, 186. So totally we have 186 dependencies in this. So let's check that those dependencies. So you can see this Professor Bal and Professor Dal are also got injected in this one. So I am removing this. Now I click on continue. So now the application loads, and that's being executed in this 5002 port. Okay, I can use this, or I can go to this Postman, and I click on get. Do I have the breakpoints? Yes, I do have the breakpoints. So I click on send. So now you can see this, the last man standing is the college DB context who doesn't have any more dependencies. That guy will get created and then gets injected here. You can see this, the college DB context that is completely populated, right? So now I remove this and then come to the business logic layer. Now, if you come and see this, the college DB context has been injected and it has got the logger and the DB context, right? So I remove this here and then come to this controller. And inside this controller, you can see this, the Professor Bal, which has got logger as well as the Professor Dal, and the Professor Dal has got the college DB context. So the entire hierarchy has been properly injected because we have already loaded that inside the inside this startup class. So what if I miss something? Okay, what if I miss something in my dependencies? Okay, let's see this scenario. So similarly, when you get this kind of exception, it will help us to identify this might be one of the reason why you're getting it. So it tries to load these dependencies and it will give you saying that unable to resolve the service dependencies. So when you get this unable to resolve the service dependencies, that one of the reason is that we might have forgotten to have these dependencies, right? So that's the quick walkthrough of our existing solution where we have the reusable component and web API. And other couple of tips we have seen how can we create the constructor when we have the dependency injection, and then we saw what the dependency injection is, how the dependency injection container gets loaded, how the dependencies are resolved. So we have seen that in this quick tour. So let's go and one more thing what we have seen is when we move this logic or the functionality to different libraries, our web API is very slim and it focuses only on the controller, what endpoints it has to expose, and only related to this controller. So it's not worrying about anything else. So all the responsibilities has been given to different libraries. Now we'll create the gRPC service and we'll test it with the client, and then we'll add the gRPC web capability also. So we'll see the benefit of doing this one, right? So let me quickly go and create. I have given the starter files also, so that will help you guys to recreate whatever I'm doing at this point of time. It will help you to recreate all the things whatever I'm doing here, right? Now let's start working on this. For the first thing, what we have to go ahead and create is we need to create the gRPC Blazor WASM. Okay. Go add new project. And I'm going to select this gRPC web. Next. And let me place this in a proper folder structure. gRPC web, it's on this one. And I click create. And this .NET 5. And I'm not enabling anything, no authentication, nothing. It's a simple one. Let's go ahead and create it. Okay. So now, what all the things which we have it at this point of time? So we have the same program where we have the start main method, and it is the startup type is startup. And here there are two important methods which we have already seen. One is this configure services, which builds this service container dependency injection container, and the HTTP pipeline is this configure configure method. And the next big piece what we have here is this app settings, where we can go and have our configuration injected over here. And next thing is I will go and make this as a startup class. And the next big piece what we have is the gRPC server, and we have the launch settings where we can go and change the port numbers. So if you come and see what all the port numbers, there are multiple ways to do. Some of the ways is either my personal choice, or either that's how I know how to do it. So let me show that. So you can come in here and you can modify those things from here also. And my personal choice is I just go and modify it from here. So I can modify this. And also when you come to, let me select this as a startup project. When you come and select this project and go to this launch settings over here, you can see that whatever the two profiles which we are seeing here are there here. You can see this IIS Express and College Web API. So similarly in here also, in this gRPC web also, we have that launch settings file, and it has only the project one. So it runs only in the project. It doesn't run in IIS Express as of now. So here is this one port. So it runs on 5000 and 5001, and this port is 5002 and 5003. So the ports are a little different. And there is something known as the .proto file. There's a Google port buff file where you will have the service definition, and you will have the RPC methods, what all the RPC methods which we are exposing here. And each of this RPC method can take one or more parameters. If there are no parameters, it will be Google port buff empty. And if you have some parameters, you will write it as part of the messages. So if you consider what are these messages are in plain terms. They are the inputs which are coming in and outputs which are going on. We can consider it as a class. And that being said, let's see that implementation of that is over here. So we have this gRPC service, and it's coming from greeter base. So what is this base class? Who is creating all these things? So we should get that as our query. So let's see that. You can expand this and go to the OBJ and debug .NET 5. And inside this protos, you can see this gRPC and the greet gRPC and greet CS. So this name, whichever is greet, has been derived from this over here, greet.proto. So it will get greet grpc.cs, greet cs. So greet grpc.cs is the one which will have this service definition. So you can come inside and you can expand this, and you can see that the namespace, whatever the namespace is coming in from here, whatever the namespace which we specify over here in this proto will be the namespace. And you can see this greeter, the service name is a greeter. So that's the one which is here, the partial class, and greeter is a partial class. If you scroll down a little bit down, what you can see is, you can see that there is an abstract class, and that class is called as a greeter base. And inside that abstract class, we have the say hello method. Now you can come and correlate that. So the say hello method is a RPC method which we have defined inside the service, and that has been marked as a virtual method inside this greeter base. So now you can correlate that. Okay, so who's this creating this greeter base? Is the tools, the gRPC tools is creating this for us. So we are implementing that. So that's one of the other tip. So let's come in here in this greet.cs, and we'll expand this. The moment you see reflection, you need to understand that, okay, some kind of transformation is happening. So what happened is here the inputs and output, whatever is coming, is an object, and that has to be transferred into binary, and that binary will get traversed or sent to and fro in a binary form. So that clearly shows that the one without the gRPC, that's for this messages or the classes. I'm calling it as a classes in a plain vanilla terms. So if you come and scroll a little bit down, you can see that the field number, whatever the number we specify over here, this is not the value assignment. This is the ordinal position. That means we are telling that we are telling that in this message or in this class, this field has got this. That means it is the first field which has to come. So it helps in identifying from which location to which location I need to do transformation from object to binary and binary to object. For that reason, we need to know that. So that's one other tip. Okay, so that's pretty good. So let's start building our let's start building our gRPC, whatever we want to do now. Okay, so for that reason, what I'll do is I'll place these two side by side, so it will help me move a little faster. Speaker series, mobconf, this one, source. Okay, we are here in this gRPC web. Okay, so there is a proto file. So let me copy this gRPC proto from here till here, and we'll look into that. So what does this proto file contains? This proto file contains, similarly, we have one service, we have two RPC methods, set of messages. Right. So one new thing, whatever we are seeing in here is the empty. That means void. We are not sending any inputs to this service method, and it returns all professors response. And another one to concentrate is timestamp. So what is this timestamp? Let's see that in a moment, and let's come back and let's see this. So you can see Google timestamp is made up of two components. This timestamp is made up of two components. It is seconds and nanos. Okay, which is a little bit different from the C# date time. So just we need to understand that one tip. That's it. So now what happened is we have added this. Let me build the solution. We expect to see the similar files which are getting generated. Like we have seen that greet.proto, it has created the server components, and it has created the server components. Before jumping in, I have to give you guys another tip of this NuGet package. Let me come in here and right mouse click on this, go and manage NuGet packages. And you can see this at this point of time, we have one NuGet package, and that NuGet package is called as a meta package, right? So meta package is like when you get an invitation, it's like family and friends. So the meta package is, it brings in itself and the packages on which it depends, and any third-party packages on which though dependent packages are there. So that's the meta package. Let's quickly look into this for a moment. And here is one. And when you go and click on that, so it's dependencies is it's a meta package. So you can go and check this. What does meta package means? It has got a dependency on a Google port buff and server client and gRPC tools. So gRPC tools is a guy who generates all those resources, whatever we needed, maybe the client components or the server components. So we expect once we built everything perfectly, we expect that there should be the files, whatever we have dropped it. So there are no files. We see that we perfectly dropped it here, the college proto, but it didn't generate anything. So let's do one more probing. What did we miss? So right mouse click on that, go to properties. So when I go to properties, it is clearly telling that build action is port buff compiler, and it is creating the server only component. You can create server and client only, or server components. So at this point of time, it is creating the server components, but it recognizes that it's a server side. Now I do a right mouse click and properties, and I don't see that. It says the build action is none. So the project is not recognizing this as as what it should do. We didn't give the instruction. So one of the way to do is we need to come into this CS proj and write down that college, right, and do a build. And then we'll go into this guy, and you see that, boom, we have our college gRPC. So all those now you understand that where is this namespace coming in from, and where is this is the name of the service, and this is the one it creates the service.base, and it's an abstract class, and we had two methods, all professors. We have two methods. Those two methods has been defined here: get all professors, get professor by ID as a virtual. Now you guys have pretty good, strong foundational blocks. What this gRPC files are, and what is this proto file, and how does it creates it. So we have to inform the tooling that what is our intention, what kind of artifacts we need. So that's pretty much. So let's go and build the service. So the service is just an implementation of the base class. Or we have seen that abstract class over there. I'm just dropping it over here, and let's have a quick glance at this. And do we need SQL Server? We will get those dependencies. We need those two dependencies. Let's come in here. I just mentioned all the steps, guys, here. So what all the things which we are going to do, everything I just mentioned it, steps, what packages, what changes we need to do, everything I've mentioned it here. Okay. So the next important thing is we need to bring in those project dependencies. Technically, these will be the NuGet packages. I'm bringing in these three. And apart from that, I need to bring in the automapper also. I need to bring in that automapper dependencies. So there are multiple ways, guys. Again, I just want to show one this way and one the other way. The personal choice of mine. So I go here, I get the I get this dependencies, and I did that. I can do that way. Okay, that dependencies got it. And the other way is I just double click this, it opens up. And if I have a existing project which is already referencing, I just copy this and observe over this on the left side, on the extreme left bottom. The moment I come and I paste it and do a control save, you can see this guy go and gets the you see this, it restored this package. So either way I do, you can do that or this. I mean, this is my personal choice. I do it to save time for some reason. Okay, now you can come and see this. We have all those dependencies, whatever we needed, we have it here. Okay, so now the moment we added those dependencies, all this issues has been resolved. Okay, one thing is for that automapper, I need to create a mapping. So let me go and grab this guy mappings from here. Let me drop that guy into this project, the mappings. So why do we need mapping is, if you see that we are doing the we are transferring the values from if you see this is a professor object, but what the proto tells that proto says that get professor's response. So from the C# type to Google port buff type. So for that we need the automapper. Instead of, if not, what we have to do is we have to do like one by one transformation from one field to another field, one field to another field. So just to avoid all these things, I'm just having this automapper. And one thing, as I was mentioning initially, the difference between the source is the C# type, and the destination should be the destination should be the Google Port Buff timestamp, and that is made up of nanos and seconds. So from datetime, so we need to transfer that this datetime system.datetime object to timestamp. So that's one tip here. Okay, so that's pretty good. After doing all these things, so are we good? So one other thing, we are not yet good. We have to do few other changes over here. So what are those changes? Let's do that. I just mentioned it everything over here, but let me go and do that. So the first thing is let me go grab this app settings and then we'll talk. There's nothing in this app settings. Okay, so I'm grabbing these three. That's for, I'm allowing the cars also, because instead of coming back to avoid delay, I'm just doing this. Microsoft extensions, that's the configuration which we have to read it, and that's the configuration. And we spoke about that user secrets. You can click on this user secrets because I'm using that user secrets over here. What I can do is I can go grab this ID and come back here and paste it. So technically when I do right mouse click and manage user secrets, it's going to open up the same file, because I'm using the same file, because both the web API as well as the gRPC both are using the same credentials. So I don't need to do something new. Okay, so we are doing that. And after doing that, what we have to do is we have to enable the cars, and this is for the auto mapper, and the other one is for the application dependencies. We have seen that how the dependency services are getting loaded. We have seen that in depth. If needed, we can see, but it might be the overkill. So I'm just resolving all these squigglies. DB context. So all these squigglies are gone. Good. So all the squigglies are gone. So right mouse click and remove. For some reason, I don't like those unused usings, even though they don't hurt me. So the other important things is we need to expose the gRPC web, so that we can be communicated using this Windows client or any kind of .NET Core clients, as well as the SPA applications. Let it be the React.js or Angular or Blazor WASM. For that communication, we need to have this. Okay, so these two things we need to add it over here after routing. Specifically, I have added the comment also that should be between the routing and use endpoints. And one more thing is here. Okay, so if you don't enable this gRPC and you do like this, that means you're exposing the gRPC service, but they have to communicate in a different channel. So we'll see that in a moment. I will come in here. I don't know, for some reason this was not working. It was working in 3.0. Maybe I'm missing something. I'm not sure. Debug. Because I just used to change only this configuration. I don't do anything, but it was working in 3.1. So let's execute this gRPC server and see, are we good? Okay, so that gRPC service is being executed. So what do we do to test this? We will need a couple of gRPC clients, which I have already created. So this is one of the console client. I had an existing project. So let me go here. Let me grab this console client. That's one type of client. And let's grab the Windows client also. Let's go grab the Windows client. So just to be sure that we are bringing in the content from this guy, I'll place the debugger over here so that we'll know that we are retrieving the content from the gRPC service. Okay, I just start this gRPC service. We are not coming through the web channel, guys. We are coming through the regular gRPC service channel. We are not at there. Okay, so what we can do is I can start this Windows Forms client. It's a simple Windows Forms client. Let me place this guy over here, and the Windows Forms is here. So let me go grab one of the ID. I'll grab ID of Mithun Nair, and let me quickly come in here and place this over here. And then I will delete all this content, can leave it there. I just click on find professor. So you can see that the call has come in here, and it is going and grabbing the content. So that shows that we are communicating with the gRPC service, and I do continue, and that you can see this, the Mithun Nair's information is here. So a lot of those debug is coming in. So the one difference what we can see here is when we do a request, here it clearly says that it is gRPC service. When we are coming through the gRPC web channel, at that time it says that the gRPC web. So here it is just mentioning gRPC. That means we are not coming through the web channel. So to do the web channel, we have to do something else. So for that reason, what I did is I already have opened up the console application so that we don't need to again and again go and click those buttons. So .NET run this. I'm running the gRPC web again, and this time what I do is I will come and mention this. Oh, okay. I just need to give a couple of other tips. So how do we create these clients? That's what we do. What we do is I just, for the sake, I just delete this. Okay, so we just need to, and also I will come in here and delete all these things also. I will delete all these things. 1, 2, 3. Okay, I delete all these references also. Or what we have to do is we have to come into this. This is one of the way, guys. This is one of the way, whatever I'm showing. Come and click on this connected services, click on add, and select this gRPC, and then click on next, and go and browse the file. The file is over here. The protos, select the college proto, and the moment you select, this is little intelligent. It selected that we want the client, but stay little focused and careful. When we try to do the same in Blazor Wasm, it selects the server because we are hosting that. So it assumes that we want to create Blazor Wasm or expose this gRPC from the Blazor Wasm project. You do the same in Web API. When you try to reference this proto file, again it selects that. So be a little careful when you are doing this. We have to select that and click on finish. The moment you click on finish, it identifies what all the dependencies are there. It itself will go and bring in all the dependencies. Okay, that's the one thing we do it. Okay, so I just do a save of that and minimize this. And another thing is the helper. It's pretty straightforward, very simple. Just create a channel for the service URL and the service client. And again, who does create the service client? We have already seen that in depth, but let's spend quick 10 seconds on that. You can come back to this debug and go to this college gRPC. And inside this college gRPC, see the difference. The gRPC is the service or client, and only the college without any suffix that is related to the messages. So if you scroll down, here it creates the gRPC client. So previously it created the service name base, and the service name client means it is creating the client components. So we create that. So that's the only difference when we are creating either the server components or the client components. The tool takes care of that. But what do you do? Okay, so let's do one more quick round of testing. So let me, the gRPC server is being executed. Yes, the gRPC server is running in here. I'll just place it over here and then quickly come in and check the debug and start a new instance. And let's see that real quick. I'll place this and this side by side. You can see that it's asking to enter the name. So let me go and grab Scott Rudy's ID. And oh, where's this gRPC? Okay, you see this, the request has come and we have seen it has executed this. And it is mentioning that it is gRPC call. The channel is not gRPC web. And I do continue, and you can see that it flushes some more logs over here, and it displays all those processes inside the table. Okay, so that's cool. So now comes the Blazor WASMs. So till now, what we did is we did a gRPC, and we have added a web capability also, but we didn't utilize that web channel. So now we do that gRPC web channel. So let's go and start creating this project. Create a new project. And that's a Blazor WASM, single page application. In future episode, I will do one session on gRPC web with Angular, but for today we'll stick to Blazor WASM. And there are multiple types. It's .NET 5. It's not a server app. I want to have this Blazor WebAssembly app. It's not being hosted under core, no progressive, nothing else except this configure. This one. Okay, boom. So let's start this. Let it create. And I will come back over here. Oh shit, I just closed it. So let me go grab this all the way till here. So cd dcolon gRPC server. Wow. gRPC server, so that I know that whether I'm in the web API terminal or the gRPC terminal. Okay, just lower it a little bit and do a cd3 and cd. Okay, so now we are good. So let me come back over here and I'll select this as a startup project. We need to do few things. The first thing, we'll execute this and we'll see that what all the things which are getting downloaded. I will change this, and also let me go here and change this to 0, 1, 2, 3. This should be 4 and 5. Okay. So, oh, and this is my convention, guys. You're free to use whatever the port. Ensure that you're not stamping over others' foot. Okay. Let's wait for 1 minute. It takes a little bit time for the first time execution. If I do Control-Shift-I, and let me place this here. So please focus on that. So let's see in the network tab what all the things which are getting downloaded for the first time. You see that? Okay, so everything. You see that all the DLLs, the entire libraries, whatever is needed, everything is getting downloaded to the client. So it will not happen from the next time onwards. Once it gets downloaded, it will start using also our Blazor WASM and also .NET WASM, the WebAssembly. Everything will get downloaded at the first time. Now we see that I will do right mouse click, empty cache, and hard reload. Now it's not downloading anything because those guys are already in. So it will not do that. That happens only for the first time, guys. So be little careful whenever you do. But rest of the things, everything is here. Now, if I come to fetch data and it's going and bringing in from the call, it's a server side call, and you see this, the button click. Technically, the button click, we don't see any action or any flickering also. So everything is happening on the client side until unless you go to bring in some content from the network. You see this, anything I do, traverse over here or click this button, do anything until unless I want to go grab the content from the server. Except that, all the things will happen on the client side itself. That's one particular trip. Okay, so the next thing is, let's work on the beautification for some time. The beautification is, I just created those files, and let's go grab this where I'm. This is the same. This is the same. Okay, I'm in the starter file, right? Let me go to this starter file and go to this Blazor WASM, and here in dub root, I need to drop in this guy, app settings, because we need to have this for the URL. So let me go drop it over here, come back and expand this. Content, I do always copy. So all I have is here the path, right? So that's one thing. And the next thing is, if you come and see here, we have few CSS files. So we have Bootstrap, Iconic, and app.css. This guy has got pretty much all the stylings, whatever we see is coming in from here. And another thing what we have is this in the main layout. So that main layout is there, and you can see some of the stylings are coming from this CSS over here. So we need to modify a few of the things. Let's start modifying one by one, and let's take it from there. The starter files. Okay, I did that. Now I need to bring in this app.cs from the starter files to the CSS folder and app.cs over here. Okay, and that's one thing. And the next thing what I want to do is, I want to create this shared folder which has got a menu option. So at this point of time, we have only 3 menu options over here. We have menu options for home, counter, and fetch data. So we don't have any other thing for here. Now what does this fetch data is? If you come in here, we'll discuss about this in length shortly. But that's the @ page. So it recognizes the route for this particular component. So fetch data. So that's how the routes which we will define. Okay, so let me close this for a moment and bring in all these components, and then we will start discussing. Did I drop this guy? So I will go to this CSS file and drop this guy. Okay, that's done. And the next thing what I need is, I need to have this shared, and inside that shared, let me bring in all these guys. So at least we'll see that the components are components and an extra menu item, and then we'll make some more changes. First, let's see the UI, how the visual look and feel has changed. So let me go execute it. So at this point of time, I'm not executing any REST API or this. So let's see this for a moment. Now, again, I'll just place it for our benefit. Okay. Now you see this, some of the visual look and feel has changed. Some of the things will be changed in a moment. So sometimes what happens is it doesn't load that. So we need to do this. Okay. So after that is changed, one second. Main menu, make dark, and this app.cs. Ooh, it didn't. Looks like I copied somewhere else. Looks like I copied things somewhere else. 1 second, let me check that. Okay. No, I copied the proper one. It should. 1 second. So let's see that. That is there. And let me check this one moment, please. The layout, make dark, everything is there. Yeah, everything is there. Okay, so we don't have that. So let me do empty reload the cache. So actually it has got the px-4 that I removed it, but for some reason it's not taking. But let's park that aside. We'll come and check about the look and feel little later. And the first thing what we can do is, anyone who worked in web forms, they know that at this point of time, if you see this fetch data, it is having the markup, and also it has got the code also. It has got both. It has got the markup as well as the code. So we are not stuck to this. We can have the similar thing where we can create a CS file and move all the backend or move all the backend code to that. So let's see that how can we create. So what we need to do is we need to create a file with the same name and CS, and that should be the partial class. That will be the partial class. So I create that. So it should be the partial class. Okay, so that's one thing. And the next thing what we have to do is we can come into this and remove all the code from here. We don't need this. Okay, we have removed the code from here, and then we can bring in this code and place it here. Okay, so you can see this, the HTTP client. Okay, some of the dependencies I need to bring in. Let me go grab this dependencies. Okay, these things are dependencies. Okay, here I faced whatever I faced is one small thing which I want to show. I'm going and grabbing the proto file from the server. So here, see this, it is considering it as a server. So I said I want client, and it is bringing in this client, and for some reason it's not bringing in this package. So as we have seen in the previous clients, when you go and check the previous clients, the dependencies are these 3 dependencies for any client. So that's what I'm going to do. I'm going to come into this Blazor as a project and then nuke this off and go grab these things. Okay, I think I'm good now. So I just grabbed it, and it takes time. You can focus on here. It will bring all those packages. Let it bring those packages. In the meanwhile, while it is bringing in the packages, we can wait or do something. Let's wait. Okay, those packages are there. Cool. So the next thing what we can see here in this program.cs, the HTTP client is already injected. So when you come in here, you see this HTTP client is getting injected from there. So I do this. What's that? Why it is troubling me now? Okay, that's HTTP client. Let me remove that. So let me bring in that. And let me bring in this. Okay, so I think I left it over here. That's my problem. So okay, that squiggly is gone, and this squiggly is gone, and this quickly is gone. Okay, so JSON. So everything is all is well. So we have resolved all the things. So let me close this up and do one build so that we can see the same fetch data, whatever it was happening. It was happening from single file. Now it is happening with two different files. We have the backend like a C# and the markup, the razor. So the component entire functionality we have divided into two different things. So let's see that how it goes. We'll be done in next 10 minutes, guys. So let's quickly see that. Only for the first hit, it's going to take a little bit time. Okay, so see this, now it has come. Now you can see this. This is a markup. Okay, and what I will do is, to speed up the time, I will go and copy rest of those pages. So that will be under pages folder. All those razor markups, everything should be under the pages folder. So I will go grab those components and put it over here. What did I do? What did I do? Shit. Okay, I just dropped those. And the next important thing what we have to do is, let's discuss about this shortly. I will minimize this. I will minimize this. And as we have seen it here, and the visual look also. Okay, we'll discuss about the web API. How are we bringing the web API? The same concept. So we have the we need this professors. The professors is coming in from the common library. So let me go grab this guy, the data core, the application core. So it should come from the application core. That squiggly is gone. So we are invoking this the HTTP client method, and we are deserializing the content whatever we are receiving to this guy. Okay, so that's one thing which we are doing in here. And for the gRPC web, there is one piece we need to add it. So that piece we will add it right now. So we can go to this program.cs and copy this, and let me drop that dependency. You can see this, the HTTP client is already added. Now we are adding the gRPC related dependencies. I am clicking on that and resolving all those nuggets. Right mouse click and remove. For some reason I do that. And after that, when we come in here, the gRPC, the channel is getting injected. That's the only difference. And we have this code over here. So technically we have everything, I assume. So what do we do is, we will go ahead and start .NET run. This is the web API. I'm executing in one command, and I'm coming to another command, and I do .NET run. So you can see this, the web API is running in 5002, and this is running in 5001. Okay, so I think we are all set for this final validation. Let's give it a minute. Let's see that what all the things which are getting downloaded. So as I was mentioning, it downloads only for the first time. Okay, so let me do a clean. Now that's an server-side call, except that nothing is happening. Boom, boom, boom. Okay, so now what we do is, we go and retrieve the content from the web API. See, at this point of time, the web API is running. See that it's going and bringing in the content. So you can come and verify that we were able to hit the 5002/API/professors. It's the same endpoint. We verified it in Postman. So this guy is going and grabbing the content from from this web API. Now let's do the gRPC. Fingers crossed. Yep, let's do that. I do gRPC. So it's going and bringing in the content. You can see that the route, whatever is the route it does HTTP for the get professors in the college service. So you can see that here, as I was mentioning, it says gRPC-web. And if I come into this guy and execute this console for a moment, we did all get all professors. We did that call. So, okay. Scott Rudy. I got a Scott's, this one. And I do F10 and F10. And now you can come and see that the content. Let me execute this and then come back and show you guys the channel. See that the channel is gRPC. The channel is gRPC. That differentiates whether from which channel you're coming. So when you're coming, this is a gRPC channel. So if you scroll a little bit up, you see that that's a gRPC web channel. So anything non-web, you can come in through regular gRPC, and anything the web, you have to come in through the web channel. So there's one small difference I want to highlight over here. If you see the content in this preview, and here in this preview, this will be little bit the transformation we need to ensure. If you're getting the proper one, maybe this is how I did it. I had to do a little bit of transformation, except that nothing else. And I want to show you the final piece. Someone can ask, say, Swami, what is why do we need to use gRPC? I can't answer that, but I will show you one important thing which I observed is, see, the number of rows are same because we are hitting the same database. The number of rows is this same, and here also the number of rows is same. So let me come back over here. So it took 70 milliseconds and it took 8 milliseconds. So because as we discussed, that's fast, 24 milliseconds, and it is 8 milliseconds. So you can see the same content which is coming in, because the only difference is the same contents which is coming as part as a JSON, and the same coming in binary. So the one which is coming in binary is will traverse. It will be smaller comparatively, and also the gRPC is on HTTP2, so it will get the benefits of HTTP2. So the entire code is here, guys, in this repository. As I was mentioning, I've given you the URL also, and also I've given the steps also, so step by step, and what changes you have to do, and how can you verify what files you have to do. Everything I've given you, and also the you have the starter folder also, but you don't need to depend on the starter folder, because whatever the complete exercise which we did it, I'll check in next 5 to 10 minutes. Next 5 minutes I'll check in, so you will have the entire code here. But you can walk through this documentation, try recreating using the starter file. Okay, that's it from me, Swami, and thank you so much for joining this afternoon. You're mute. You're mute.
All right, thank you, Swami. With that, we are about to wrap up the event. Before doing that, I want to share a couple of things. Please let me know when you see my screen. A couple of things you need to do. You need to go to the share feedback URL and share your feedback around, again about the event, so that we can improve further and bring many more events for you. And also all the sessions will be there on the YouTube channel itself. It will be in the .NET Foundation channel, exactly the same URL which you are using right now. You can always come back and watch the recordings during your free time if you have missed anything in between. So I would like to thank Nish and Swami for the wonderful sessions. And also I want to bring in a couple of people who were helping us with conducting this event. Please, Abdul and Miroslav, if you can bring your video feed. I just want to. Yeah, these are the producers behind the scenes who are helping us with the video, the content, and the layout you're seeing on the screen, and with the chat and the moderation and all. Big thank you to them also, and also for Dave who helped us setting this up. Thank you. And last but not the least, thank you all attendees for joining us on this Saturday. It was a pleasure hosting you all. Thank you. So don't forget to share the feedback.
Thank you.
All right. Bye bye.